of the presentation here, and Makoto from Japan. So it's a good spirit. I have heard recently many comparisons between the asteroid problem and COVID problem. So this is an ongoing discussion. My sense right now is that COVID kind of hijacked the asteroid case, but there's a lot of lesson learned that could be learned from that. So hopefully some of this will be talked about during today's presentations. We do want to have to give an opportunity to Mark. Mark Boslow is a active scientist. He is a physicist. He was a member of the technical staff at Sandia National Laboratories, and he's an adjunct professor at the University of New Mexico. He's an expert in the study of planetary impacts and global catastrophes. So he will not be able to give a full talk, but I'd like to introduce him, and he's going to talk about the special event, the context of today's event, which is Asteroid Day. So Mark, please go ahead.
Thank you, Nahum, and I'm very happy to be here. I'd like to thank AIAA and the organizers. I really regret that I can't spend the entire meeting. It looks like a great program. A lot of my friends, a lot of very interesting subject matter, and it's timed well in association with Asteroid Day. And normally at this time of year, I'm in Luxembourg. We do a program called Asteroid Day Live. And that's broadcast from Luxembourg. I've been there the last 3 years. We have panel discussions, and there is going to be an Asteroid Day Live this year, although it's not going to be live. We've already pre-recorded our panel discussions, and I am on a panel that will be broadcast on Tuesday. Although I just checked the asteroidday.org website, and they have ongoing programming. So when this is over, when today's program here is over, there's plenty of stuff to look at, plenty of material to continue watching, and you can watch it all next week. But the main event is on Tuesday, June 30th, Asteroid. That was designated as Asteroid Day. It's an official United Nations Day, and it was chosen to be June 30th because that's the anniversary of the biggest impact in historical times, the biggest confirmed impact, and that was Tunguska, June 30th, 1908. So Tuesday will be June 30th. There will be a lot of programming, including the panel that I was on, which is about scientific simulations and visualizations. So I talk a little bit about my role in that, modeling the formation of the Libyan desert glass. And I actually pulled a couple pieces of this stuff out of my filing cabinet, and we'll hold up one for you. So this is a glass that's found in the western desert of Egypt, and it was very much a mystery for many years. People speculated about what might have caused it, everything from the pharaohs developed nuclear weapons to aliens, but those aren't scientific ideas. So we needed to explain the Libyan desert glass in terms of natural phenomena. We knew that asteroids impact the Earth, and sometimes they generate airbursts, large explosions, natural explosions, but with energies of the scale of nuclear explosions. And those are actually a risk. Tunguska was a small version of that. The Libyan desert glass forming event was probably a bigger version of that event and could endanger a lot of people. So Asteroid Day was started, I first found out about it when I attended a meeting in 2014 called Starmus at the Canary Islands, and filmmaker Greg Richter's, he premiered his film 55 Degrees North, which is an asteroid disaster movie. And Brian May, who is an astronomer and also the lead guitarist for Queen, scored the music for his film. And so they got together with Rusty Schweikart, the Apollo 9 astronaut, and Danica Remy, who is the president of the B612 Foundation. and they founded this organization called Asteroid Day. And it became very popular. They asked me to, Rusty asked me to join him in putting together an expert panel so that we could ensure that all the information that comes out of Asteroid Day is scientifically accurate. So we make sure that we vet everything, and we also answer questions if there's a question that comes up, or if something is in the news. I mean, there are often stories that are either overhyped or wrong, and so we make sure that we keep people well informed. Rusty was the chair of that panel for a while. He stepped down, and I'm now chair of the panel, and I think there's about 20 of us, 20 members of the panel now. So please go to asteroidday.org. You can see live programming now, and you can find links to the expert panel and to other information about asteroids. So thank you.
Mark,
I'm sorry I have to leave. I really wish I could stay, but I have a conflict. I'm giving a keynote for another organization that's having their annual meeting today, the New Mexican Coalition for Excellence in Science and Mathematics Education.
Mark, thank you so much. A quick question: is this the 6th time we are celebrating this event?
This is the 3rd year in a row that we've done our Asteroid Day live broadcast, but this is the first one that's not actually live, although it's still called Asteroid Day Live, and I think we're going to kind of pretend that it's live.
All right, thank you.
This is what you have to do during a pandemic.
Thank you so much. Keep doing the good work on saving the world, and
okay.
We'll talk soon.
Thanks, and I wish I could stick around for this whole program. It looks great.
Thank you so much. Thank you. Okay, so I think now it is, we'll clap our hands. Now it is my time. Ken, thank you very much for introducing me. And I'm going to give a general introduction. Let me share my screen here. And I believe that you should be seeing my screen now. Tell me if you do. You do. Okay, good. Yes. Okay, thank you. All right, so this is a general introduction to the topic of planetary defense. Why should we be worried about the asteroid problem? It's a presentation that I gave in a few places. It's cleared by Aerospace Corporation, so it's available to the general public. It is a shortened version of the class that I teach at Aerospace. It's a one-day class, and this is just touching the main topics. The general areas that we are going to talk about are related to the near-Earth object problem. Near-Earth object refers to objects on orbits that can bring them near the Earth. These are called NEOs, asteroids, or comets. On the right side, you see a picture that was created by my daughter. Her name is Shavit. And we're going to talk about some impact evidence. We'll show where things have impacted our planet. We'll talk about the risk to our planet today and in the future. We'll talk about how we find those objects and what to do about them, and make an assessment of where we are today. Talk a little bit about the mitigation method, and specifically about an application. It's a collaboration between Aerospace Corporation and JPL, or NASA's JPL, to develop a web-based application simulation, realistic, that uses fictitious asteroids on realistic orbits to tell us how we could deflect a real object that might come our way one day. The belief among the community of planetary defenders is that it's a question of when and not if. So asteroids and comets are those space rocks that orbit the sun just like we do. And when their orbits bring them close enough to the Earth, they have the potential of being in close proximity. And that's why we call them near-Earth objects. There is evidence that those objects struck our planet throughout its history, and they are continuing to strike our planet today and probably into the future. A collision probability of an impact by a significant object is exceedingly low, but the consequences could be catastrophic. And therefore, my key message is that it would be prudent to understand the nature of the neohazard and prepare to address it before it becomes a crisis. And so what I'm really selling you is asteroid insurance. As you can see on the right side, this is a cartoon that was created by one of my friends at Aerospace. Here is a typical illustration of the orbits. In green, you see the orbit of the Earth around the Sun, and in blue, the orbit of a typical near-Earth asteroid. As you can see here at the top, the orbit of the asteroid comes very close to the orbit of the Earth, so the two objects have the potential to be in a close proximity to one another, the asteroid and the Earth. And that's why they call it a near-Earth asteroid. In red, you can see an orbit that actually intersects with the orbit of the Earth, and therefore those objects have the potential to be at the same location at the same time, creating a collision. So this is these type of objects are called potentially hazardous objects because they have an actual likelihood of colliding with our planet Earth. A little bit of a dictionary about those objects. A comet is a rocky object that typically resides in the outer regions of the solar system, probably created together with the rest of the solar system, kind of leftover materials. When it comes near the sun on an elliptical orbit, the ices and dust that typically are found on the surface of this object would be lifted off and creating a tail that is illuminated by the light of the sun. So what we typically see is the tail of the comet. We typically cannot see the object itself, it's too far. An asteroid is a similar small, dry, rocky body, typically orbiting the sun between the planets of Mars and Jupiter. And when a small piece breaks off any of these, it's called a meteoroid. This is a piece that kind of meanders around the solar system, and these are typically the objects that find themselves colliding with planet Earth. We are being bombarded by this daily bombardment of small pieces that enter into the atmosphere, and when they are large enough, they can create a phenomenon that's called shooting stars. A meteor is the light phenomena that occurs when any of these objects passes through the atmosphere. There's some misnomer and misconception about it. The meteor is not an object, it's just a phenomena, a light phenomena. And it was first created by the ancient Greeks, thought that those explosions are related to some meteorological phenomena because they knew nothing about objects that can come from outer space. When the object does make it down to the ground, it's called a meteorite. And here is an example of a meteorite that was found in Argentina. There's thousands of these that are found, and you can actually buy some of them. I know that Mark Boslow has a good collection of these. So this is an actual meteorite that was found in Argentina several hundred years ago. Let's look at some of the impact evidence. Small objects hit our atmosphere continuously. You can see here a map of objects that entered into the atmosphere in the last 3 decades. There are over 800 what is called fireballs because they leave their energy in the atmosphere. They usually do not make it down to the ground. And they are caught by the US government sensors of varying levels of energy. These are actual collisions of objects with the Earth. Some of them have substantial amount of energy. We are going to talk a little later about the Chelyabinsk object. About 7 years ago, collided over the city of Chelyabinsk in Russia and injured about 1,500 people. Today, we are aware of about a couple of hundred impact evidence locations around our Earth. If you look at the moon, you see how it is cratered. And those craters were created by impacts of asteroids into the moon. We live in the same neighborhood of the solar system, obviously, so we were hit by similar flux of objects, but they were mostly raised by the geological activities found here on planet Earth. But there's a few hundred of these locations that are found. So one of the interesting questions that we are thinking are, well, how those objects have affected civilization or could affect future life on Earth. One of the examples is a potential comet explosion that occurred over North America about 13,000 years ago. It was assumed to be calculated to be fairly large in size, perhaps as much as 4 kilometers across. And at about the same time, the Clovis people, which were some initial primitive civilization that lives in North America and lived off the mammoth hunting, they disappeared. They eventually died out, including the mammoth. You can see some evidence to that in this rock formation in Arizona, where the top part of the limestone is separated by some black mat, some algal growth from the top part, and the bottom part of the stone includes mammoth skeletons and fossils versus none that can be found on the top part. So there was a mass extinction of the mammoth at around 13,000 years ago by some dark event. And so the assumption is that it affected this civilization. Another example is the discovery of a crater about 2 miles wide crater in southern Iraq, I think about 12 years ago. They dated the formation of the crater to about 4,300 years ago, so 2300 BC. And at about the same time, there was mass collapse of civilizations in this region and mass migration from the Fertile Crescent region to Egypt for food. It's recorded in many cultural historical records. And so seems that those events potentially have influenced civilizations because in this particular case, it must have ignited humongous brush fires in the region and disrupted the food supplies of these civilizations. So there is a potential for disruption of existing civilizations in the not too distant history. Probably the most famous event that is known to everyone is the extinction of the dinosaurs. Here is a picture of 2 famous geologists. These are Berkeley geologists, Alvarez. The young person here traveled to Italy to investigate the magnetic field of the Earth, and he found this region of limestone that's separated by a layer of red clay. And he was really interested to know what this red clay layer represents. So they cut a piece of it, brought it back to Berkeley, and analyzed the material contents. What they found is that in the limestone, down from below the layer, there's abundance of dinosaurs fossils, but none can be found in the layer above that red clay layer. The red clay layer, which is dated to about 66 million years ago, contains 6 times amount of iridium than can be found on Earth. And iridium is a known element that comes with asteroids. And so they said a large asteroid must have hit this region and caused the extinction of the dinosaurs. Where could it be? Where could be the location of the impact? It is today accepted that the location was in the Yucatan Peninsula in North Mexico, and it created a crater of about 180 kilometers across. How do we know that? If we would travel to this region, there would be no crater visible. So it was found by doing a geological survey of the bottom of the ocean, the ground, the bottom of the ocean. There is oil exploration that is done in this region, and the oil companies are interested to know where is the best place to dig for oil. They found those gravitational anomalies at the bottom of the ocean, circular in shape, up to 180 kilometers across, that cannot be explained by any usual geological activities of the Earth. And so they concluded that this is the region where the asteroid hit. It was estimated to be about 10 kilometers across. And I read that recently there were some expeditions, they uncovered some materials from deep beneath the surface and found that this material is rich in iridium. So there is many points that points of evidence that point that this is the location. Moreover, exactly across from this location in India, there's a region that shows that there were periodic massive volcanic eruptions in that region of the world. And at about the same time as the asteroid impacted Yucatan Peninsula, the rate of eruptions have doubled, which is now presumed to contribute to the extinction of the dinosaurs. It must have raised humongous amount of dust into the atmosphere, cooled off the earth. The dinosaurs are cold blood creatures, and they probably just perished out of lack of sun and food supply to them. So the question is, of course, is what would it look like if an object the size of the asteroid that caused the extinction of the dinosaurs would hit today? And this is a picture that was put to scale. Here is downtown LA, and this is the comet that the European Space Agency landed on a few years ago. So that's the size of the object that impacted our planet, probably at the Yucatan Peninsula location. Not a nice day, I should say, to the buildings and to the rest of the world. Another evidence is the famous meteor crater in Arizona. It's almost a mile across, perfectly shaped impact crater here. I recommend to visit it. It was created by a relatively small object, 30 to 50 meters iron asteroid. Highly recommended to go to the visitor center right here, look at the ball that is in distinct shape relative to the generally flat desert around it. Anybody who is interested to visit the Grand Canyon is invited to make it a small diversion. It's near the city of Flagstaff in North Arizona, and it's an amazing visit. And that's the Tunguska event that occurred in the year 1908. That's the origin of the Asteroid Day movement. Again, about the same size asteroid or comet maybe exploded over Siberia in Russia, burnt out about 2,000 square kilometers of Siberian desert. And an expedition that was sent by the, I guess, Russian or Soviet government about 15 years later found that the forest was burnt and the trees were all fallen in a direction away from some epicenter. There was no crater that was formed. It must have exploded in the atmosphere, but it burnt a huge amount of forest, and the size of the forest was larger than New York, DC, the New York City, and Washington, DC. So these cities would have been destroyed if that explosion occurred over these cities, and that would be a major loss to a nation. In fact, if the same explosion had occurred just 3 hours later, Moscow would have been obliterated. It's at the same latitude. So this is basically the origin of the concern from the impact by asteroids. 7 years ago, there was another explosion over Russia, the largest landmass country here, and so they are kind of magnet to objects, and it injured about 1,500 people, mostly because it took about a couple of minutes for the shockwave to travel down from the altitude at which it exploded, and windows were imploded into the people who just watched the show. It could have been worse if the asteroid had hit at a steeper angle. The damage would have been larger, and that was a relatively small object, only about 17 meters in size. So the evidence is accumulating that we are somewhat in a shooting gallery of those objects, and it's a question of when somebody is going to get hit. Let's assess the risk from that. So this is a series of pictures that were taken in 1994 when Comet Churyumov-Gerasimenko 9 collided into the planet Jupiter. It was discovered, I think, maybe a year earlier, and it was not very long after the Hubble Space Telescope was launched into space. It was an opportunity to aim the telescope into that event and take really live pictures into the breakdown of this comet into about 21 fragments as large as 20 kilometers across that crashed into the Jovian atmosphere and created those disruptions that were larger than our planet Earth. So this would have been a really bad day if any of these pieces would have crashed into the Earth. It tells us that these kind of major collisions can occur in our days. So the question obviously that kind of comes to mind is, can it occur in our lifetime? So let's look at what NASA is doing about it. So NASA spotted what is called the Great Pumpkin, the Halloween asteroid 2015 TB45. It's about 600 meters across object that was discovered 3 weeks before a close passage with the Earth at about 1 times the distance to the moon at a humongous speed at about 35 kilometers per second relative velocity to the Earth. That was a very, very close approach, only 3 weeks before the close approach. And it raises concern if that real object would have collided with the Earth, what would we suffer? To understand that, I took my little pocket camera, went down to downtown LA on a very nice, clear day, and superimposed that object over downtown LA. And you can see that it would not be a nice day for the buildings in downtown LA, and probably much beyond downtown LA if that object picked that location for an impact. By how much? The University of Purdue has a nice tool created by the scientists of that university. And I went and placed myself 100 kilometers away from the impact location of TB 145. And I found that I would feel earthquake magnitudes 7.5 earthquake magnitudes at 100 kilometers away from the impact location, 3rd-degree burns, building collapse. So this type of event is really continental. It is a massive destruction over hundreds of kilometers around the impact location. At a likelihood of 2 to 1, just because the surface of the Earth is 70% ocean or water, the asteroid would have impacted over the ocean and created a tidal wave that could extend miles, many miles inland and go as high as 18 meters to 37 meters or 120 feet high at 100 kilometers away from the impact location. We are going to, this indicative of a massive coastal damage to the region around the impact location. So that would have been a massive disaster, somewhere on the continental scale devastation level and below a global catastrophe threshold, especially that today's economies are interconnected and societies are interconnected. So think about evacuating North America in 3 weeks, or Europe in 3 weeks, or Asia in 3 weeks. Is this something that is conceivable? That's a real object that came very, very close to us. How many of these are known to us today? As of just a few days ago, we are aware of over 23,000 near-Earth objects that have been discovered so far. The really big ones that can cause global damage, let's say those that are 1 kilometer and larger, are mostly discovered. We are just not finding many of them anymore nowadays, which allows NASA to say that they found probably 95% of the really big ones, and none of them is threatening in the next century or so. But the rate of discovery of the medium and small one is accelerating with more telescopes being pointed out to find them. And the notion is that in the next few decades, that's going to increase to probably many dozens, if not hundreds of thousands of near-Earth objects that will be discovered and put into the catalog. And so we are kind of a little bit in the dark ages relative to what we know about the medium and small objects, to put a major emphasis on their discovery. Here is an interesting experiment that I've done here with the data that's available to us today, all taken from the JPL website here. JPL has a very nice website that was put together. The link to it is at the right bottom part of the screen here. You're welcome to go visit it and learn a lot about the topic. And what I've done here, I filtered those objects that are not trivially small and passed at a distance closer than 1 times the distance to the moon, which is right here, in the last year. And you can see here there are a few city killers that could have impacted us. One of them was just at the distance of 19% the distance to the moon. Mind you that the geosynchronous satellites at about 10% the distance to the moon. So this was barely just above our satellites, an object that could have destroyed a small country instantaneously anywhere around the globe or create a significant tidal wave into a coastal region. And here's an object that was even larger in size that passed just a few days ago at about 80% the distance to the moon. It would have caused regional devastation. Let me say a few more things about these objects, and let's look when they were discovered. The objects highlighted in red here were discovered after their close approach with the Earth, which means that if any of these objects had picked us for a target, we would hear it in the news and not on the JPL website. So we would see some regional devastation or maybe a country being destroyed. We would have heard about it in the news. That is part of the concern. We have to find them before they find us. Another example is, let's see what's going on around the planet literally now as we speak. So again, this is a snapshot that I took a few days ago, and you can see that in the very near future, or literally in essentially almost today, we have a few of these objects that are sizable and can cause devastation. So we should be aware of this risk. This is a situational awareness type of exercise. That particular object, the second one here in green, was discovered 10 years ago, which gives us an opportunity to potentially do something about it. It's a fairly medium-sized object, fairly large. It could destroy a fairly large region if it impacted us. We have an opportunity to do something about it if we have a plan that designed to mitigate. 6 months, maybe we could do something about it if we had pre-built system ready to go. Maybe we can, blow it out, disrupt it. But those that are days and few weeks prior to impact with the Earth, there's not much we can do today. Essentially, we cannot do anything except evacuation and disaster response. This is the reality in which we live. I invite you to go and visit that URL here on the JPL website and do your own searches there. So in summary, this gives us an impression that we live in a shooting gallery. And that shooting gallery tells us that some of those big objects here that impacted us in the last 110 years at a distance shorter than the distance to the moon could have impacted us and changed the world the way we know it. We were just lucky not to be impacted by those objects in the last century or so. Why invest in the discovery and tracking of asteroids? Of course, they can make us extinct. This is an obvious thing. Some of those big ones can really change life on Earth. But on the other hand, they can make us rich. They can contribute to the bottom line of those companies that are now being created to do space mining, object mining. Here's an example of an object that is estimated in the trillions because of the materials found on it. If you can bring just a small chunk of it and bring it to the Earth, you can probably make some profit or perhaps create some materials for space operations, in situ space operations, fuel and construction material. It definitely would erase the US debt. So that's the motivation to invest in those. The same technology that would be required to reach out to those objects and do profit-making operations is the same technology that would be required to reach out to the object and deflect it or destroy it for planetary defense purposes. And so that's why I believe that we should basically collaborate between those two organizations, two objectives, to defend the Earth, but also make a profit if the object is benign. So we need to remember that those objects orbit the sun over millions of years, many orbits before they find us, which gives us an opportunity to find those before they find us. Uh, uh, we would like to characterize those objects. The characterization of these objects with early discovery will allow us to understand their orbit, their size, their mass, composition, rotation rate, and these are critical parameters for designing a mission, a mitigation mission for deflection or distraction. We really need to know, we need to have the best knowledge and as early as possible about those objects in order to design mitigation missions. The discovery is done by both government telescopes and amateur telescopes. Here's an example of the Pan-STAR telescope in Hawaii that I think is responsible for the discovery of the majority of the objects that are put into the catalog. And the way it discovers, it takes pictures that try to find objects that move across the night sky and find objects that either were not there or just moving across. And these are put into the database with the best parameters of orbit determination, trying to figure out the likelihood of impact with the Earth in the future. Initially, when the object is observed and we have very few observations, the uncertainty about the orbit is large. And so we don't really know whether the object is going to impact with the Earth or not. But as more observations are taken, the accuracy of the orbit is improved, and we move from region A to B to C, where the uncertainty of the object is reduced. That kind of situation creates a dilemma, a decision dilemma. Let's imagine that Earth was included in region A, and because Earth is included in region A with very few measurements, there is some amount of likelihood of impact. We put it on the plot on the left side right there. Over time, we take more measurements and we reduce the region of uncertainty to region B. And if the Earth is still included in region B, then the likelihood of impact is going to increase. In the vast majority of cases, eventually Earth is going to fall out of the region of uncertainty. The likelihood will fall to zero when it will be safe. But as we have seen in the previous few slides, there are rare occasions, very rare occasions where the object decides to impact with the Earth and the likelihood will rise to 100%. But the question is, what do we do at the onset of that curve? What should we decide when the likelihood is small and the uncertainty is high? Should we do something when it is the least expensive and we have the most mitigation options, knowing that it most likely will be unnecessary with additional measurements? Or should we wait to get more information and decide when the object is somewhere there, and if it is not going to fall to zero but rise to 100%, we are going to be faced with a much more expensive campaign and much fewer options, if any. This is an existing decision dilemma of what to do about the topic. It's one of the topics that is being discussed at the planetary defense conferences, at workshops, at meetings. What's the best approach to handle a situation which could literally be severe in consequences? What can we do? Well, there is essentially two options: deflection or distraction of the object. Deflection typically takes a few years to accomplish because we need to reach out to the object and give it a nudge and wait a few years for the missed distance to develop. Distraction is also possible on some of the objects, and both of these are being considered today in terms of mitigation methods. In some cases, civil response, disaster response will be the only way to do on small object or very short warning situations. How do we know that we can actually do that? I believe that next month there is a NASA mission that's going to be launched with a spacecraft that's going to collide with a small asteroid that is actually a moon of a larger asteroid. Both of these are non-threatening asteroids. And the purpose of this experiment is to test a method of deflection that's called the kinetic impact. So the spacecraft is going to collide with the moon of the asteroid. and change its rotational period around the big asteroid by a small amount. And that change in rotational period is going to be measured from the Earth. And that's one of the reasons why this particular target was selected, because we can actually make the calculations of by how much the rotational period will change and measure it from the Earth to know if we can actually deflect asteroids with a spacecraft. Another possibility of an impact, it's more rare but could be more devastating, is by a comet. Comet is an object that comes from the outer region of the solar system. It can actually appear from any direction, not just the orbit of the Earth around the sun. It could actually come from above and be discovered in the last minute, typically at a very fast speed and a very short warning time of perhaps a year or two at the most. And what can you do about it? Because we live on the Earth, any rocket that we would launch from the Earth, we can view the Earth as a launch pad for these rockets. It's going to largely follow the orbit of the Earth around the sun. It cannot just make a 90 degrees turn and go impact into the comet that comes from above. But we found a solution in which we use solar panels and the solar wind to bend the orbit of a spacecraft into such an orbit that we can intercept the comet at several months before the approach, maybe at around 2 astronomical units from the Earth. And at that point, in deep space, it would be safe to blow it up. So this is one of the solutions that we analyzed here at Earth. Another thing that we looked at, well, let's say one of these objects, probably a small one, relatively small one, escaped our telescopes and it's on its way to collide with our Earth. It's about to enter the atmosphere. We have maybe an hour or two. What can we do? Well, we have the technology to shoot missiles out of the sky. Why not use the same technology to shoot asteroids out of the sky? So we calculated, and it is possible. The idea here is that if we let the asteroid enter without any breakup, it's going to break up at a low altitude and release its energy over maybe an undesirable location. But if we can launch a missile to disrupt the object, break it into small pieces, increase its surface area, it might release its energy at higher altitude, dilute the impact on the ground and save the day on some key location. So we calculated and we actually can intercept those objects with existing technology if we design the system to do that. And moreover, we also calculated what's going to happen to the asteroid with several projectiles that would impact the asteroid and pulverize it into small pieces. And we can literally save the day in the very last minute over a key city that we would like to protect. I'm sure each one of you knows a few of these cities that you would like to save. Other things that I do is I give talks at local schools to inspire the next generation of scientists and engineers. And here's one of them where I saw many hands lifted up when I say, who would like to be an astronaut? And many of these kids said, me. So I'm sure that some of them might choose to go into the fields of STEM. And also I am a member of the organizing committee and chairing those planetary defense conferences that we hold every other year. This one was held in Japan 3 years ago. Here's me and my son. We wrote a paper together and presented it at the conference. And this is the conference that we held last year in DC. And again, me and Nicola is next to me, is going to talk soon. And I'm sure there is more familiar faces around here. The next conference is going to be held in Vienna and Zoom, or some combination of this. And another thing that came out of our activities at Aerospace is participation in the movie that Phil is putting together, has put together, and is about to talk about it in a short time. And this is just a snapshot of me delivering my class at Aerospace and filmed by Phil's team. Finally, the app that we developed with NASA, well, how do you actually deflect those objects? So this is an ongoing project collaboration between Aerospace and JPL. It's called the Neo Deflection App, or NDA. On the upper left part, you can see a panel, a control panel, where you can design the parameters of a mission and characterize the object, which shows the orbit of the object, the orbit of the asteroid, the orbit of the Earth, and the location of the impact of the object in the Earth. And the outcome of the deflection mission would move this impact location to outside of that red circle, which means that we were able to avert an impact with the Earth. We are also developing a game version of that app, and that game version is going to hopefully increase the outreach and the awareness of the general public, rather than use a kind of a rather technical tool. It's going to be hopefully a fun game to play. It's going to be a physics-based game. We are retaining the physics of the app in the game. So all of the objects in this game are moving according to the orbital mechanics laws and the way rockets are launched. So it's going to be a realistic game similar to the app on the aerospace, on the JPL website. This is a quick demonstration of how the app looks like. We can select from a list of several dozen fictitious asteroids. None of them are a real one. And we can characterize the size and view the impact location. All of them are designed to be inside the red circle, meaning an impact with the Earth. So what we can do is change the time of launch of a rocket into the asteroid by moving those knobs. And when we move it, we can see that the location of this object change in the Earth, in the orbit, and we were able to move the location from the red dot to the green dot. That's not a good thing because somebody is going to complain. So we can also control the time at which the spacecraft will collide with the asteroid and do the deflection. And this is what we like to call it aerospace mission success. We were able to move the asteroid outside of the red circle and avert an impact with the Earth and create a missed distance of about 0.6, the radius of the Earth. With that, I am going to conclude my introduction here. I hope that I was able to convince you that the asteroid problem is a real one, and it is posed a national security concern that we would like to understand and prepare for by increasing awareness, education, and develop our response capability. First step, obviously, is the detection. Most of the effort is going into detection nowadays. Many telescopes are being put in place, including in-space discovery capability that hopefully will become available soon. The next step would be characterization of their orbits, their sizes, and their materials that will help both national security objectives and those companies that would like to utilize those materials for their industries. So we would like to improve our technology readiness for mitigation of the asteroid problem, and keep in mind that this is really an international, it's a global problem. So we need to develop those policies and processes and collaborate with the space holders and stakeholders and develop the tools that will help us to make the correct decisions. And ask the questions, how is our space program coming along? And with that, I'd like to thank you. My part is complete. So now, Ken, I think we are going to move to the next, unless there is a question, Ken. Okay, maybe we'll leave the questions to the end, and we will move to the next talk, which will be by Nicola. And so I think I'm not sharing anymore. And Nicola, you can go ahead.
Perfect.
So,
can you see? Can you hear me?
Yes, we can hear you. And
yes.
Nicola, do you want to introduce yourself, or do you want me to read the intro? Maybe you should introduce yourself because you're going to probably do a better job in that. So Nicola, please do.
Yeah. Okay, so I am a political scientist from Czech Republic, European Union, planet Earth, which is something I like to write every time somebody's asking me for my nationality. I've been studying political science with focus on critical security studies. And during the end of my doctorate, my PhD, which is about 5-6 years ago, I found out that there's going to be a planetary defense team project organized by International Space University in the United States, which actually was led by Madhu Thangavelu, who is also in the group in the presentation at this conference. And the time I finished my PhD on a completely different topic on cybersecurity and how cybersecurity is constructed as a policy problem, and decided to focus on planetary defense and more space-related projects. So currently, we have a project on planetary defense and asteroid mining, which is supposed to recommend our government how to proceed with some planetary defense policy, various scientific projects, and how to put together the scientific community which we have in Czech Republic and elsewhere around within the European Union mainly. And moreover, we started working with Breakthrough Initiative on the Starshot project, where we are currently helping them to establish what we call pools, the peaceful use of lasers in space, which is actually the follow-up of all the ideas which we have developed with Madhu Thangavelu about 5 years ago at the team project. So my presentation is going to be mainly about, let's say, the way of thinking which we wanted to present in the Planetary Defense book, where we put together, let's say, more political science-oriented topics with let's say topics which are well established within the planetary defense field. I mean, astrophysics, the problem of orbital mechanics, and some risk assessment, etc. But the point of the book was to introduce the community a little bit different way of thinking, which is actually the purpose of political science, to introduce a different perceptions on what the planetary defense efforts are currently doing and where it can head, and what are the desirable ends, which I guess and I believe we fully share. But the book was meant to say introduce a completely new, more cosmopolitan way of thinking, that planetary defense is not only a case we need to solve, but planetary defense is an opportunity which can help us to constitute a new international order and international modes of cooperation rather than order. So let's move forward. And when it comes to my introduction, I'm currently a leader of a newly established Center for Governance of Emerging Technologies at the Institute of International Relations, which is an expert body for the Czech MFA. And I am also part of say the academics, the Faculty of Social Sciences, Charles University. And beginning the next year, I will also be teaching at the Faculty of Arts in Prague. So I'm teaching at 2 faculties, and I'm leading a research center, which is currently mainly focusing on space and these projects: planetary defense, asteroid mining, development of the regime of peaceful use of lasers in space for the Ministry of Foreign Affairs, which is somehow say pushing forward the agenda in cooperation with other countries which are interested. So let's move forward to the presentation. I will try to stick. Can I have another slide, please?
Give me the next slide.
Yes. Yeah, I will try to be really short when it comes to the introduction of the theoretical thinking, but at the same time, I think it's the most important part of the book, of the book on planetary defense, where we introduce that there are some ideas within the political science, and those ideas can be really well established within the planetary defense community, and can help us to somehow reconfigure or let's say properly direct the planetary defense efforts. So when it comes to the security, the concept of security in political science is not an objective concept. It's a concept which various schools of scholars are interpreting variously. For neorealists, it's more or less national security. So it's a security of a nation state. The traditional cosmopolitans are having these subject as a humankind who's supposed to be secure. But what is interesting in the most recent move in cosmopolitan thinking is these ethical security scholars who develop a new branch of critical security studies, and they are saying, if we are securing only humankind, we are necessarily not putting into an insecure situation the others. We can secure, let's say, our activities when it comes to, say, oil mining, so we will have transpiration, but at the same time, we are causing some harm to the earth. So the security cosmopolitans are more focusing on the biosphere, as a subject which is supposed to be secured. So security for which values? Now realists would usually say that independence and territorial integrity, these 400 years long traditional concepts and the vital interest of the nation state, while the traditional cosmopolitans will say, okay, so it's universal human rights. So that's something what we have been talking about the whole 20th century. But the security cosmopolitans are currently coming with the idea that, the point is that you are not securing somebody from a possible threat. You are establishing conditions, which is securing the possibility to flourish, which is securing the well-being of humankind and the biosphere. So how much security? The neorealist would say, okay, so enough to deter. The whole strategic thinking in international relations for decades have been about deterrence. But deterrence usually leads to security dilemma, because security dilemma says, okay, if one state is trying to secure himself as much as possible, it's rising the insecurity of the other states. The common problem between US and the Soviet Union during the Cold War. So the traditional cosmopolitans would say not to fail with the general ethics, while the security cosmopolitan would say to cooperate and flourish. And this is, the key point of the whole book. We are trying, to explain that the whole planetary defense, and Nahum was actually talking about it when he was talking about the possibilities of mining the asteroids. So the point is that if we will be able to establish infrastructure in space, which will help us to mine asteroids, the same infrastructure might help us also to deflect the asteroids. And the deflection of the asteroids will not be a decades-long project, but can be a very quick reaction to actual found threat. Can I have another slide, please? Next slide, please.
Okay, 1 second. Yeah, I hear you. 1 second.
Yeah.
1 second.
So the security cosmopolitan ethics is arguing that all actors bear to create deep and enduring security for all human beings. So it's our responsibility, which is our responsibility in the US, our responsibility in the EU, our responsibility in Asia to cooperate, because in that way we will be able to establish a policy which will help us to, let's say, address the problem of planetary defense. A commitment to consider the long-term impact of present-day actions on future generations. This is a really important part when it comes to climate change, because we need to solve the problem in long term, not in the short term, because the next generations will need to be able to somehow continue with the policies which we will introduce today. So in planetary defense, this can be very quickly translated between the whole infrastructure, which can be somehow developed now. I mean, the beginning can be developed now, and then the next generations can continue with the development. But now it's the time to simply think what are, let's say, the desirable ends in this, long-term perspectives. The third one, acceptance of the global categorical imperative of security. Security actors must behave as if the consequences of their actions will become global. And that's another, important part which can be very well applied on planetary defense. If we will introduce nuclear weapons for planetary defense, I can imagine that, for example, North Korea will come up with the idea that they simply want to be also, the country in the world who will be able and who will have the capability to defend the planet, not necessarily for the whole humanity, but necessarily for their own empowerment, and that's the arrest for the local community, for the local citizens. So it will be finally North Korea arguing that we are so big power that we can defend the planet, and the local citizens will listen to it. So in that perspective, the security cosmopolitan says, you as a politician should not focus on topics which will ensure your power in your country, but which will ensure that it somehow nourish the international cooperation. So Anthony Burke says that security cosmopolitanism is not an ideal thought, but a compelling strategic imperative. That security cosmopolitanism needs to explain us and needs to somehow enforce us in a way of thinking which will not put the others in an insecure situation. So how can we reach that objective? Ulrich Beck said that by having a cosmopolitan outlook, and Anthony Burke says by the imagination to act. Burke, by the way, is saying that security cosmopolitanism is not going to come. It has to be imagined. So if we have a very interesting case in planetary defense, we have the opportunity to somehow develop a substance for the security cosmopolitan theory in a practical way. So can I have another slide, please? And this is a very interesting debate in political science in the last 30 years. And Jenna Nima actually wrote an article about 5 years ago when she said, you all folks who are the critical security scholars are actually dividing your arguments into these four dimensions. So the negative security and positive security. Negative security in the analytic way is producing you the absence of threat. So the policy which is developed in this way, in a negative security and in an analytical way of thinking, will might you put in a situation that we will have the capabilities to defend ourselves from the asteroids. However, in a normative way, it does not necessarily bring good because, for example, the nuclear weapons can defend you from the asteroid, but at the same time can put you into a situation that North Korea will be developing their own nuclear weapons. In a positive security approach, the analytic says, okay, so let's think about state of security, which will give us something more, some additional like outcomes. So in the normative way, it's a desirable state of security, good security. So it's actually the desirable end state. So how can we reach it? How can we imagine it? Do we need to formulate it in an analytic or in a normative way? So I believe in a normative way because in the analytic way you can find out how to solve the problem, but in the normative way you will find out what solving this problem will cause to the society. So can I have another slide, please? And justifiable securitization is another interesting theory. Securitization is a theory which was developed by Barry Boson and two other scholars in Copenhagen school, and they are arguing that, and the whole theory somehow moved with the political science in the last 30 years and created a whole new branch of research. So in their application, they are looking for hidden intentions of those who are securitizing some possible threats. So when it comes to planetary defense, we have a really great advantage that we can have a perfect observation of solar system. So we can say, okay, so we know where are the asteroids, and we have less than 1% probability that we missed asteroids bigger than 10 meters. Let's say it's an ideal state. We are not already there. And if we are saying, okay, so we need to have the means to defend the planet unless even in the moment when we don't have this perfect observation. So we are actually securitizing the problem, and we are somehow trying to defend various policies which are exceptional, not like on a normal policies which we have like on a daily basis, but exceptional politics. So a nice example of securitization situation is that you say that trees along the roads are a threat to the drivers, instead of saying that we need to lower the speed on the road in order to let the drivers go through smoothly. So what's the desirable end? Having the trees along the road, or and lower down the speed, or let's say letting the drivers riding very fast and kill the trees while the drivers will actually kill each other when they crash to each other. So Rita Floyd came up with an idea that there might be some situations that we can securitize the thing in a justifiable way. So objective existential threat is one condition. Planetary defense perfectly fulfill this condition. Legitimate referent object, human well-being defined as the satisfaction of human needs. If we focus on planetary defense, not necessarily as a possible extinction even, but as a case that can help us to develop space infrastructure and let us become a spacefaring species, then we will contribute to the human well-being in that visionary way as the space folks are usually surrounded by. So appropriateness of the response, survival and sincere intentions. So at the same time, you need to introduce a state of security which will provide you conditions in which you survive, but at the same time you need to have sincere intentions in a way that let's say the policies you are introducing are actually addressing the problem you at the same time in the securitization process introduced. So imagine a situation with another example with the nuclear weapons. For the North Korea, there will probably not be sincere intentions in defending the planet, because for them, introducing nuclear weapons as a possible planetary defense infrastructure would help the local political establishment to stay in power. While probably we would like to believe that some democracies like the European Union or the United States would have these sincere intentions, but we cannot be sure. And the point of the justifiable securitization is that this is the question we need to answer. Are these policies introduced in addressing particular insecurities sincere, or they are not? And on the slide, please. Yeah, and there are some like moments now in which you apply the knowledge now on these questions of possible insecurities now, and the knowledge might be considered as being an objective knowledge now. And when it comes to planetary defense, this is probably the first moment in various centuries that we have a civilian scientific branch which is funded by public funds and which will provide us information for possible mining. And this is an interesting question which we heard at the Luxembourg several times when the question was raised there that where is the moment when the astronomers will not provide their data, because their data can be very well used for the mining of the asteroids. Yeah, and but at the same time, this data can help us for defending the planet. So what are these data? Are these data like are supposed to should these data be publicly accessible or not in this context for what the data are used? So in that perspective, what is a desirable state of security? Climate equal to particular parameters or a livable environment. So that's the definition of the desirable end. Because when it comes to climate change, the result, or the desirable end, is not necessarily the situation when we will have a lower temperature on the planet. The desirable end is the livable environment. But how can we define the livable environment? When it comes to planetary defense, the desirable end is much more easier, because we can say, okay, so the desirable end is to have the perfect observation. So we can use kinetic impactors on every possible impactor which can hit Earth, because we have that knowledge when the asteroids are. So in that perspective, science actually defines the problem and solutions, but social science can help us to define the desirable ends. And if these two approaches are somehow reconciled and capable to listen to each other, we can develop planetary defense in a way that will not necessarily only defend the planet, but will actually help us to develop the infrastructure to help the humankind flourish. Can I have another slide, please? Yeah, I think I don't have enough time because I'm running out of time. So I will be very quick here then. The pragmatic practice-oriented way on pragmatism, it's actually the practical way how to apply all the theory I have been talking about until today, until now in the presentation. In the reflexive pragmatism, Jenna Neyman argues that our desirable end cannot be very well defined at the beginning, but can be somehow studied on the way and assessed in that iterations in the circles in which we are deploying the policy on planetary defense. In that way, a nice example, in the Czech Republic, about 10 years ago, there was a government introduced subsidies for solar panels. So big companies built big solar panels across the country. Finally, the result is that the energy development from the renewable sources is not that centralized, but it's still centralized into the big companies who actually invested the time into that business. However, today, if you say raise the topic of solar panels, the photovoltaic panels, as a policy idea, and how to, let's say, fulfill the Green New Deal we actually have accepted by the European Parliament. Solar panels are somehow considered not, the approach, because people still link it, are linking the photovoltaic panels to these, business barons who made a lot of money on it. If you go to Germany, you see so many buildings fully covered by the photovoltaic panels. The point in pragmatist-oriented way is that you learn from your mistakes, and you can somehow reformulate and reevaluate the policy in more ethical ways, and you are not immediately shutting down the idea and going fully away from it. So the reflexive pragmatism is somehow asking practical questions, but at the same time it is asking what are the normative implications of that policy. So is it providing free energy to the society, or it's providing only free energy to somebody? Okay, so next slide, please. And at the end of the book, and by the way, Anthony Burke wrote the introduction for the book because he became really not necessarily surprised, but like he was very happy that we used his security cosmopolitanism theory and applied on planetary defense topic. So we met actually later in Australia, and we're thinking about how the security cosmopolitanism as a theoretical approach can be introduced into practical policy and practical politics. And it's not an easy way how to do it, but as he said, you need to imagine a world in which you would like to live. And if you can do it in a way that it will somehow link these values with practical solutions and practical problems, then the politicians might actually think about it. If you move forward to the thinking of Ulrich Beck, when he said, we need to simply go over the national outlook and start thinking in a cosmopolitan way, and to somehow establish the cosmopolitan outlook. He considered national outlook, not cosmopolitan outlook. This is a mistake in my presentation, as a prison error of identity, because the cosmopolitan way of thinking actually argues that there is no reason to have divisions or distinctions between various nations only because somebody draw the lines across the earth. When it comes to planetary defense, what we like to say, and what somehow I would say shaked with the last planetary defense conference, because it was across various media, including Washington Post, I guess, was that my colleague said, asteroid is not discriminating. Asteroid will simply fall somewhere. And if we we continue thinking in a national, or with the national outlook, we might have a capability to defend ourselves if the asteroid hits actually our nation. But if it is going not to hit our country, but our neighbor, are we going to cooperate or not? There was an interesting situation, by the way, at the Planetary Defense Conference during the simulation, that the asteroid was crossing Nigeria, and they were considering, or there was a discussion whether to use nuclear weapons or not. And some people said, if you start considering about nuclear weapons, Nigeria have a really good deposit of uranium. So if they have enough time to begin mining the uranium, and you will not provide them the security from the asteroid, which might actually fall into Nigeria, then you will have to accept the fact that they will mine the uranium, and you have another nuclear power in the world only because of the asteroid. So cosmopolitan outlook in that perspective is simply the necessity, the strategic imperative. Ken Booth was the one who introduced the security plus concept I was talking about during the 90s. So what we have to do is to have the knowledge means, but we need also to will and to have power to change the world in this way. So can I have another slide, please? So what is the desirable end? Planet secure from asteroids by the most effective means, or planet flourishing because of no asteroid threat, which includes human biosphere enabling social and social and physical structure for reaching this end. So what are the variations? Nuclear warheads ready? Is it providing us that possible human and biosphere flourishing? perfect solar system awareness. It's a nice example I was talking about. Planet secure global politics serve collaboration. Semi-prepared with kinetic impactors. We are only semi-secure, but there is a full collaboration. We have a nice example now with DART and Hera mission between NASA and ESA. Solar system infrastructure will actually serve humanity, will serve the biosphere, and will help us to establish humankind as a spacefaring species, but at the same time can help us to defend the planet. So can I have another slide, please? And this is the practical application what we are currently actually doing. We wrote down a declaration for the scientists in the laser technologies. And you know, the whole purpose of the declaration was, let's develop an international scientific community, and finally maybe an association or an institution which can be, you know, imagined as a CERN-like organization, which will help us to develop laser applications for space. We went to various laboratories all around the world in the last 2 years, and we heard one single problem. If we have the laser powerful enough, the national security folks will immediately step in and classify our research. At the same time, we saw installations where, and there are, you know, dozens of them around the world for decades already, which are mapping the orbital debris. At the same time, the same installations are using the same optics for more powerful lasers, which are classified. And some of them seems to be capable and powerful enough to deorbit the orbital debris. Soon or later, we will need a practical way how to deorbit that billions of pieces, or we will simply not be able to go to space. And that's, you know, the point of human flourishing. So at the same time, we might not have, you know, enough powerful lasers for planetary defense, and we are finishing a research with the Institute of Plasma Physics in Prague, who are simulating various lasers or using various lasers in the laboratory against actual meteorites. So we will see their results soon as we will publish it, and it doesn't look good for the lasers for the planetary defense. But at the same time, these lasers can be used for interstellar travel, and that's the breakthrough initiative Starshot project. However, if you would like to build such a laser, which is currently imagined as being 220 gigawatt laser, put somewhere into the desert, on the mountains, or anywhere where you would imagine, it will be immediately considered as a dual-use technology, useful not only to deorbit or propel orbital debris or propel small probes to the deep space. So what's let's say the key, or what's the solution for such a situation of neo-realist security dilemma problem? So this is our answer. The answer is to introduce a declaration by scientific community, which will develop that normative framework I was talking about before. Actually help to develop this security regime, which our Ministry of Foreign Affairs is currently working on, introduce it at the United Nations, and develop the CERN-like organization for laser development. So the question is, could have the large technical systems here actual high power lasers and constitutive effects for more inclusive global governance? We think yes, because the problem of lasers is exactly the dual use possibility. And if you have small nations working on laser development, they will sooner or later have, you know, high power lasers. So what would be the answer, we believe, of the big powers to become part of that CERN-like organization for laser development? Can I have another slide, please? So this is a shortened version of the roadmap we would like to develop, and which would not necessarily only answer the planetary defense, but will help us to develop possible lasers which can be used for planetary defense if they are powerful enough in several decades. But at the same time, these lasers will be also probably helpful in propelling nanoprobes to Proxima Centauri or elsewhere. So the idea is, and there is a nice example with lasers, because if you start talking about lasers, people will immediately, and lasers powerful enough to propel nanoprobes to Proxima Centauri, people will immediately answer you with Death Star from Star Wars. So this is the effect of popular culture, that people don't think about lasers as instruments for becoming spacefaring species, because Star Wars have been so successful in somehow, providing us these under consciousness images of Death Stars. So the policies and politics of various nations understandably, react in the same way. So spread the idea in relevant communities, develop this grassroots movement, develop an inspirational narrative that lasers are possible civilian instruments, and draft global governance system, which will include the organization and the security regime, and organize the critical mass of states willing to jointly found and fund the Terran-like organization. So the peaceful use of lasers initiative is, after 5 years and all of that thinking and writing the book on planetary defense, the kind of outcome where we think that the humanity should go in the following decades. So thank you for your attention. I hope I didn't steal too much time. And I hope that I was able to explain it comprehensively. Thank you.
Thank you, Nicola. Very, very interesting talk. I think you pointed out some opportunities for collaboration and opportunities for investment, and opportunities to simply think about it, in a more deep way than just technologies. I think we are a bit short of time here for questions. Can people reach out to you if they have specific questions about the topic that you are researching?
Sorry, I couldn't hear you now, Geraldine.
So I'm saying that we are going to move to the next talk now because we are a bit behind on schedule, and I'm hoping that people can reach out to you with questions about the topic that you just talked about. Thank you very much, and I suggest that we talk soon.
Thank you.
Thank you, Nicola. Okay, so I think our next talk is going to be by Professor Madhu Tangavalu. Is he online?
Hello, can you hear me? No?
Yes, I can hear you loud and clear.
Oh, great. Okay, so now let me share some slides. I'm going to go to my slide set here and see if we can pick up.
Ken, can you make Madhu slide appear?
Me? Did you send me your slide? I thought you were going to share on your end.
I'm going to run it if that is okay. Yeah.
Oh, there we go. Okay.
Are you able to see my slides?
We are
Only
seeing...
the folders. You need to share the screen and then pick up the slide you opened.
Okay, is that good?
No?
Hold on.
Did you email me?
Madhu, we are seeing your file.
Okay.
You could try double clicking.
Okay, now we can see your slides.
Oh, good. Okay, good. Thank you so much for a wonderful introduction, Nahum and Nicola, my friend. It's a pleasure to hear you all. And to the rest of you, happy COVID times. It reminds us that we are a global species. Us versus them does not work very well. I'll run through a lot of slides here. We can discuss later. Let me try to move through. So I want to talk a little bit about how the Earth-Moon system perhaps can evolve, starting with orbital debris that Nicola kindly left off on. I teach a course in creativity, and Nahum is the reviewer in the class. We are interested in creating ideas. Many of them may not be feasible, but it's very important that you have an idea and that you present your idea. One idea is about using lasers, just as Nicola was dropping at the last in the last slides. We think that it could possibly be a way to move the planetary defense into an acceptable arena for the whole world. It is very clear now that we're going to be putting a lot of things into orbit, particularly in low Earth orbit. And it seems in a few days we'll be launching again a few more satellites, and before you know it, it'll be quite a crowd. Astronomers are already up in arms. And we have some extremely valuable assets in space, including the International Space Station. What is the effect on the system is still being weighed, and we want to be careful. So obviously we think global collaboration is needed, and there are several things at the UN that's happening that may be useful. We have a method of tracking that is very, very developed and maturing. In fact, we are able to track very small objects in space, and we've been doing that for many years. And then this idea that we had a thought that maybe placing some equipment, high power lasers around the world would be a very useful thing to do. And we have studied many ways. I'm sorry that Professor Lubin is not with us, but he got us all excited about using a battery of lasers to make it viable. Lasers can do magical things from the ground, and we know it can be done. We've had several papers, including in the International Astronautical Academy, and mainly it says that you can fry things that come to you using very developed and high power lasers that Nicola is now pushing in his Pulse project. So space station is a very valuable system, and now whenever you have a potential debris collision, the technique is to hide and wait for it to pass. I don't think that is the way things are moving. We think that we will have the possibility of laser mitigation on both stations, so that you can fry these little objects as well. Again, there are tremendous policy issues with it. And so the thought arises that directed energy line of sight mitigation is something that we must pursue, even if we think the technology is not mature enough for many, many reasons that I will follow up with. So it is considered a space weapon. It's very simply put. When Nicola's group was at the Space University meeting in Ohio, this was raised, and we've already known that it is a space weapon. Now, talking about the moon, we know that in the coming few years, we're going to be putting a lot of objects into space. And the question then arises, how do we protect them from meteor showers that Nahum talked about? And one method is to have lasers that can fry these little objects as they come along. So there are not dual, but multiple uses for high power lasers. Here's a depiction of a high power laser. Another one which tells you that gangs of equipment can be placed all around the globe, on the moon, and more importantly on Earth, that can be used in tandem to mitigate these objects. So planetary defense, as Nuhu mentioned, is about observation and detection, interception, and neutralization. And most of the time we spend our thinking in this area because that is where we really have begun the program. And I think it's high time we start to think about other things to do. Mainly, we are talking about a lot of literature dealing with observation and detection. And it's been my pet P, that we should continue to do things also in mitigation. Now, as Nuhu mentioned in his closing slides, comets are visitors extrasolar sometimes. They can come to you very fast, very extremely high energy. If you think asteroids are bad, wait till you visit or see a comet whizzing by. And so in general, if you look, circumspect about planetary defense, we are not prepared. The good part is that we are aware of this and we are trying to expand public awareness. Again, the current philosophy is to study NEOs to improve detection and study collision probability. And most of them deal with long-term strategies, how to deflect or move an asteroid by a narrow margin that'll save planet Earth. But then I like to think that probability and all of the machinations we use is not really reality. And because one fine morning, if you see an object coming to you on a terminal trajectory, we don't have anything right now to deal with. Now, there is a term in psychiatry, and it is known as anosognosia. That is, it affects all our species, I like to think. That is, being blindsided because we are not preparing ourselves to think widely enough. Nate Silver, the baseball statistician, has written a great book called The Signal and the Noise. And in it, he talks about this, that we have a tendency that to confuse the unfamiliar with the improbable. And the contingency we have not considered seriously looks strange, and what is improbable need not be considered seriously. This is the way we think. And but again, the reality is vastly different from probability and statistical evidence. We use statistical evidence and probability in quantum mechanics. That's why we call it a theory. And it's not accepted in the classical physical world even today. So, as you know, things like UMAMO, we have seen them coming through because we are getting more sensitized to our solar system and the happenings around us. Now, if you ask me why doesn't it hit often, again, it's a question of probability, and we like to think that these things don't happen all the time until it happens. So we have to evolve as a species, and I recall talking about this at the ISU meeting with Nicola and others, that we are evolving from what we call space situational awareness to a new evolutionary thinking which expands our mind. We are thinking about solar system situational awareness, and soon we think we will also have some ideas on what our galaxy is up to, galactic situational awareness. We did this drawing, it's a little bit wrong, but it still tells you that we need to be thinking about how to protect not only the Earth, but the Earth-Moon system, because the Moon is as important to planet Earth as the planet Earth is important to us. I like to think that it's high time that at the next planetary defense meeting in Nahum, that we think about emergency threat level gates. My own feeling is that we should consider something in the order of 1 AU, 1 astronomical unit. And if a comet's coming to you in a 1 astronomical unit distance, that is the distance from the Earth to the Sun, and you could look at it reverse to from the Earth outward into solar system of 1 AU, a comet will reach you in about a month's time. And that is kind of in a time to do some things if we plan correctly. By the time it gets to the moon, you have a few hours to prepare. And by the time you're on level 3, you have to duck and cover, pray as our old NASA administrator Bolton said. So we have these ideas that we can put things in place that can be kind of very useful uses besides just asteroid protection or cometary protection. As you know, nuclear comes up in every planetary defense conference. It is extreme thorny issues. It was brought up at ISU. Everybody was up in arms, and it continues to this day. And it has tremendous difficulties. Now, you should not confuse the B612 with the B6112. I think that is another area that you want to be thinking about, because it has caused a lot of problems in the deterrence arena, and it's a lecture for another day. Now, why I brought that up is because if you look at the budgets that are spent, and in our own country here in the United States of America, you will think this is impossible, but it's happening now. Of the discretionary budget, more than half of it was spent in 2015 for defense. Now, it is still the same compared to what we spent on general science, which is a small sliver of which NASA and other agencies participate. So this is the chunk of area that you can really, really push to make things happen. So we're thinking that defense and civilian activities must collaborate in things like planetary defense. This is how it looks like. The United States of America spends more than the next 10 powers of the world to defend itself and its various allies around the world. Nothing can compare with this amount of money that is being spent. And hopefully to keep the experiment of the free world alive that Abraham Lincoln talks about, the last best hope on earth. So let me talk a little bit about what the military and the defense system can do for you. We have incredibly large and important assets all around the planet, going 24/7 and locating all kinds of materials. The information system that is transmitted by our defense industry is such that you cannot have any nation on Earth, on this planet, or in our solar system, or in our galaxy, compare with what is available to us at brief notice. So there are several areas within the defense that are constantly working to coordinate the action. The Joint Special Operations Command is the people who take over when it's time to execute some very, very important and national security issues. We need to know this. The MDA, the BMDS. There are many areas where international cooperation is already happening in the defense industry. And as Nicola mentioned, one clean area of investigation that many nations are involved in right now is these high power lasers. Because as you know, as the defense puts it, it is much cheaper, much cheaper to use a pulse of light to disengage and defeat an enemy than it is to provide artillery and cost for cost. I mean, it is much cheaper. Rail guns are another area where the US Navy has done some remarkable achievements. Some people think it's mothballed, but it's a very, very powerful arena. Again, clean ways of attacking a target. I produced this in a document earlier with Jim Burke, I recall, where we thought we could stage electromagnetic launchers to arrive at speeds in excess of 100 kilometers per second. So that I think you all remember the rods from God idea, where you don't need armament, you just need velocity. V equal to half mv squared to disengage and obliterate objects. In December of 2019, we have now the United States Space Force, and reorganizations are in progress, and we think it could play a very important part in planetary defense. As you know, the motto is Hic Salvare Diem. Could be Salva Diem or Carpe Diem, and it is something we can do very, very quickly if we put our forces together. All of you should be familiar with the brown, green, blue water strategy, and how Alfred Thayer Mahan, the father of that technique in naval warfare, talked about how we engage in various domains. I think we can apply that to the space domain, like close to us, Leo, further out to the moon, and further out to 1AU or something like that. We need to study this in more detail. But most of all, I want to remind you all that sometimes we miss the forest for the trees. We live in a very, very dynamic and violent universe. Cosmic velocities and energies are absolutely beyond our scale of operations. Milky Way is rotating all the time. It could be anisotropic, well, for all we know. And all of you need to remember this. Comets remind us from time to time the energies of released or in operation around the cosmos. As I said, that this movement is happening at about 500,000 miles per hour. We are moving through our Milky Way galaxy at this velocity. And to add to that, some of the stars do not follow the plane of the galaxy. I mean, these are things that astronomers know. And we think because the space between stars are so large, we should not worry about them. And yet, that we think is the cause for comets to be perturbed from the Oort cloud and come flying, zooming into us. That's what the mess looks like. The system wobbles entirely, and you have stars moving irregularly, particularly the halo orbit stars and the bulge star orbits. So we are very, very insignificant in the whole show. You may want to look at a project that we studied called the SEUS project. This is for much later on, where we can use the solar solar system resources to tackle incoming asteroids and comets. And just throw them into the way of the incoming. But those are things for later. So the capabilities are such: observation, mitigation, last resort is FEMA, aftermath. And we should pursue all these in parallel. I think the Planetary Defense Conference is starting to do that now. So essential for PD capability is end-to-end system functionality. We can start to do that with orbital debris mitigation. And once we certify that and commission that, perhaps we can get the whole world going with us. You can see the different ways of doing this. My favorite one is what Nicola taught me, called the trust and confidence building measures that we need to undertake in planetary defense. Awareness is where we are at now. And it is the same in climate change, or the pandemic that we are going through right now reminds us that we are a global species. I think it is Immanuel Kant who mentioned that it's nature that will bring us together. If we don't accept it and go by the stuff that we talk about, national sovereignty and so on, don't compare with nature, So there are different options. Architect's view is always different from an engineer or a scientist's point. Architect's view is not civilian or military response. It is always all of the above, but in a globally responsive and coordinated manner. We need a synergetic action plan. There are many, many threats facing us, as severe as asteroids. The solar mass ejections is a very, very scary threat. Ocean methane release is a big threat. Pandemics, bioterrorism, all very big threats. So we think a cosmopolitan issue is good. And I'm glad that Nicola and others agree that we need to be thinking about it, a cosmopolitan worldview. It's not new. It's as old as the ancient Greeks. And we need to think about policies. And at some point in time, I think we will reach what we call level 5 autonomy, where we won't be thinking about it, because these kinds of activities will be in the hands of artificial intelligence, and they will diffuse the problem way off by the asteroid belt or further out, even before things happen. And I call it level 5 autonomy. And I'd rather prefer that we look at this from a viewpoint that has some amount of romantic feelings to it, like Petit Prince. I hope all of you have read this during this particular time, because I think BU612 is an organization that has done some fantastic things. With that, thank you all, and let's proceed to the next meeting.
Thank you, Madhu. Truly fascinating set of ideas and directions as always. Are you going to join the next Planetary Defense Conference?
I hope so. And where will this be? In Vienna?
Either in Vienna or on Zoom or some combination.
I will think about it. Thanks for reminding me.
Fantastic, fantastic, amazing, really cosmological scale talk. I think we'll have some questions at the end, but right now we would like, in the benefit of time, to move ahead. And I think next is going to be Dr. Serena Goldstein. And I think the best thing to do is that she introduces herself with a few words. So please, the stage is yours.
Here we go. Can everyone can hear me? Okay.
Yes, we can.
Yes.
All right. All right. Yeah. Thank you for having me. My name is Dr. Serena Goldstein. I'm a naturopathic doctor. So in the naturopathic education, the first 2 years is all conventional medicine. So from the basic science to diagnostics, blood work, imaging, and so forth. The next 2 to 3 years is all ologies and nutrition, herbs, homeopathy, chiropractic, minor surgery, IV therapy, lots of modalities. So a lot of the times when I am working with people, lots of psychology as well, but it's helping them navigate through various forms of treatment, usually starting with lifestyle first. So speaking lots of languages, and especially coming into this time, you know, I've seen a lot of, in this literally total shakeup, you know, people still have had health goals. People were still used to fitting things into their routine. Now they have a different routine. And one of the things, you know, as I've been on here for almost an hour, that I've never heard of this. I find this absolutely fascinating. I'm eating up everything. But the similarities of, there is this sense of how much the medical profession has also been butchered along, you know, these many decades as well. So there is this total kind of breakdown to breakthrough, and what happens, you know, if we can all work together and move through that fear response. So it was refreshing hearing that we are on the same page in that respect. It's bringing that awareness, you know, to everyone. Okay, so first slide. I say next one. Okay. So in, what's going on, it's a shock to the system. Any kind of war, plague, where now it's like, this has really involved the whole world. We're all on high alert. But that said, not every country is experiencing this the same way. And here in the US, we're seeing things like racism, police brutality, the media, we're getting segments of stories and different opinions. A lot of different inflammatory related issues that maybe we were able to kind of push aside before, but all of a sudden that's not happening anymore. It's exposing all these holes, and all of these holes, well, we can't just patch it up. It's more about how do we actually break it down and create what's sustainable. But once again, that also means we all work together, in a similar mindset. On the other side of things, because there's always, a dichotomy, so we can understand the differences, is that animal shelters are pretty much empty. So everyone's been adopting animals. Global health, or really the state of the globe and the world, that's been getting a lot better. All of a sudden, there's, minimal smog. So, because I know there's the whole issue with global warming as well. So all of a sudden, Mother Nature and Earth can actually regenerate herself as well. As a species, in many ways, we have been forced to slow down and really just take a step back and say, wait, is everything that we're doing, we've been going so fast, is this really all sustainable in the long run? Likening this to health, usually when I thought about, why people come to me, it's out of choice. It's because they want to make this whole health investment, and isn't this fantastic? This is a little different. We were all forced to do this. When you're forced, when you're not ready, and you as in general, it can bring up a lot. Where's the preparation? Were you mentally ready for this? It can really snowball into thoughts that maybe someone never even knew they had, that now they need to handle. And then coming back into this society, we're used to making our own decisions. Whether it's that whole commitment to health, like changing your diet and lifestyle, or maybe it's a quick drug or a quick supplement, or just, grab and go, instant gratification. So caught between, we're used to making our own choices, to now we're forced to live in a certain way, knowing we're not getting all the information, and everything little by little is being uprooted. So Abraham Maslow, a known psychologist, he had a whole hierarchy of needs. So on the bottom was all of our basic instincts. So like food, shelter, our fight or flight response, all that we need to survive. After a couple of more layers, at the very top of the pyramid was self-actualization, or our own evolution. So this is where we want to learn, we want to study, we want to better ourselves. Maybe we see some personality traits in us that, ooh, we don't like. So we think of who we want to be there, and then, strive to. Well, right now, even our basic needs are having issues being met, especially as we see a lot of monetary and financial related issues in this nation as well. So, outside, so pretty much that whole pyramid literally collapsed, and in a very short period of time, with everything that happens. Next slide. Okay. So this is a bit of what I was talking about before, how we're used to this instant gratification, we'll get what we need, and especially how much we can order things online, quick deliveries. We're just used to having things as we need, when we need, and right now. But at this point in time, even though there's a lot of speculation about the second wave, or if it's going to happen, what about a vaccine? What are some states doing? What are other states not doing? How can we work the system to get what we want? But the thing is, we don't really know, because the whole what we want isn't always what we need. So how can we trust moving forward that we could actually, whether or not we're doing the right thing, but then also trust that we can adjust, you know, each time we go along. So this is definitely bringing up a lot of issues, you know, from the personal side of going about your daily life. You know, we have people working from home now where you probably hear the kids, the spouses, the pets, and then even to, you know, so little adjustment there, and even to the global scale of people's lives have been disrupted. And now we're seeing all these protests and people getting really antsy. So everything is just from the smallest scale to the largest scale, but then how do we come together at the end of the day? And this also brings up just where was our life before and what does it need to gravitate to? A lot of the times, you know, even though this can be challenging to our basic needs and even our sense of self, how can we go through moment by moment and be living in the present? Because a lot of the times we're thinking about the future, the planning, the going, the doing. I grew up in the middle of Manhattan and went to an elite private school. It was ingrained in me from the get-go. So then what does it mean to really step back? Yes, you can have the plan, but also know that if the plan needs to be deviated, that's fine. You're not attached to it. So this is also bringing up how can we reroute and navigate, just, you know, and have the trust in ourselves from the headspace to working and having the words with others around us so we can also get done what we need to ensure that security. All right, so next slide. So talking a little bit about the virus itself, COVID has been around for decades. The issue is that it's this strain. There's a lot of different theories, you know, of where it came from. I don't have I understand where it's come from, the different opinions, but in looking at the bigger picture, at the end of the day, we're still dealing with it. And that's, you know, what we need to focus on to, you know, in the here and now. And in the sense that the virus itself, because we're kind of unsure of the origins per se, and, you know, what to agree on, it also means if we can't really all gather together, then what is the future going to look like as well? And this is what we saw, especially in the beginning, when there were even ER doctors that were unsure of, you know, how a virus like this could even exist. So all of a sudden, you have states that have different protocols, because here in the US, no one can make up their mind. I remember in the beginning, there was a lot of talk about natural medicine, like vitamin C and zinc, where a lot of my colleagues who do IV therapies were sending vitamin C IV bags to hospitals because vitamin C was so rapidly improving people. However, that was only, you know, having that on the news as some natural immune support was only around for a short period of time. And all of a sudden, that doesn't seem to be the focus anymore. There's been, you know, so many more protocols and standards per se that have been put in place. So, you know, and even in the beginning where we thought it was only going to affect the elderly, well, now we see it's affecting everyone. And the symptoms are so vague. It could be everything from asymptomatic to, you know, the moment you get sick and you're like down and out. And then even the younger people could also, I know there were some reports of like brain hemorrhages, you know, sudden cardiac events. So there really is this wide range and severity of symptoms. So once again, the path of this virus and all that, you know, because viruses can mutate, which is the problem with one of the issues with the vaccine, is that it's kind of as unknown as we're going in this day by day as well, in that metaphorical sense. The tests themselves aren't always 100% accurate. I've read a number of them, even done by my colleagues, are maybe like 70, 80%. Some may be slightly better than others. You know, same thing, even with the antibodies, it may be good to get, but that's still a snapshot in time. Who knows whether it's a week, month, you know, months plus later. And then there's just different reports in the media about, you know, how much people are really reporting, because at the same time, there's the economy and people's jobs. So we're partly caught in this catch-22, but once again, it's also creating that divisiveness of unrooting people's foundation of those basic needs. So this, yes, it's a pandemic, but it's so much more than the disease. It's really this challenging global picture and how we're all going to, you know, once again, work together and be aware of everything. The last part to this is how I put in that we are social beings. You know, even if we do like to read and be by ourselves, and, you know, I'm definitely one of those as well. At the end of the day, we are social beings. We are meant to be and converse with people. So at the end of the day, even if we are told to isolate, we have so much more technology now than when we did even like 10 years ago, you know, with social media. So, and even just having this conference online. So at least we do have the benefit of still having, you know, some interaction. So, all right, next slide. So these are a couple of different defense mechanisms. You know, when there is a fear, when there's crisis, we have all different ways of coping with it. We may say that we're doing fine, and maybe in that moment, but at the same time, if we don't really know what to look out for and what to be aware of, then how do we know what fine, you know, really is? So, for example, repression is very common. So I found the descriptions helpful, and then I'll go through some of the examples on how it could apply to here. So like in repression, you know, there's also a lot of talk that, oh, everything will go back to normal. Everything will be fine. This is in the sense of maybe someone having that gnawing feeling. They know it's not, but, you know, if they just stuff it down, it will all be fine. Denial is just, they know it's going to be fine. There is literally no, there's no perception of what's really changed, because also you need to have the perception and the acceptance that there is change going on to then also say, what can I also do about this? How can I help? How can I adjust? Projection, this is definitely something I've seen as well, especially when it comes to wearing masks. So, you know, someone could be saying like, oh, they're such a horrible person, they're not wearing a mask. And then what if the person, you know, without the mask is thinking, great, they're just part of the herd and they want to copy everyone. So while someone may think that the other one's a bad person, well, there's no awareness that the other person could either be thinking the same thing or honestly just not care. But at the end of the day, the projection is kind of putting one, you know, up against the other. Let's see, yeah, displacement. So this is if anything is happening like at home, work, any frustrations, and you wind up taking it out on your pet or your kid. So pretty much anything that's supposed to be for one thing and you're taking it out on something else. Regression is, you know, kind of like in this time, someone had their dream job, their dream career, you know, in many ways, maybe restaurant owners. And it could have been the one thing that saved them from drinking, drugs, maybe it made them change their lives. Whatever they put that onus on, then all of a sudden having it taken away, and once again, this was not a choice for it to be taken away, it was forced. And maybe the person wasn't quite ready to let it go or understand their identity separate from the attachment of, you know, that's something else. And maybe now they start reverting back to those behaviors, whether it's drinking, you know, any type of obsessive compulsive, you know, you could certainly go down the list. And sublimation is the last one, is that instead of, for example, speaking your feelings, whether it's calling a friend, writing it down, any way of, to get it out of your system, then maybe the house needs cleaning, you need to do your laundry, you want to call that friend, and you're doing all these seemingly good things. So I'll see a lot of this too. You're doing all these seemingly good things, but you're still not quite dealing with the issue at hand. And so these are just some of the examples of ways that if we are feeling unrest, that's okay. That's totally normal. Even in practice, I'll have people who may not always be super compliant 100%, and they'll be afraid to say something. And I'm like, no, that's okay. If you need to express yourself and do something different, let us work together. Let us figure out what helps ease your mind. So once again, we're recalibrating right now in many different ways. So even just taking it step by step, that's, you're already doing, you're already climbing a huge mountain. As they say, it always starts with one step. So, all right, next slide. To understand where we are as well, we also need to take a look at some of the history. And as a species, we've evolved really quickly in the past 500–600+ years. And then especially post the Industrial Revolution. I mean, even the rise of social media and how that's taken off exponentially, that was what, maybe 10 years ago, which is a really small fraction of time compared to, how long this Earth has been around as well. So we've evolved so fast in the way food has been made and produced, how much mass marketing, the consumerism, just everything that we're like getting, taking, moving on with. So all of a sudden it's become now to this point of, well, can the Earth also really sustain this as well? And so, it's where I chatted a bit about that before. And so that's on the global scale. Can the Earth really sustain this? And then this is your time. There's always going to be a dichotomy of what's out there. So balancing, what we really need to work on and adjust. But at the same time, there's people who are getting, on their deathbed saying, we want to know that we contributed to the world. We want to know we contributed to someone's life, that we're satisfied with our life. So on the flip side, there's also a lot of people now saying, which we're also seeing on that global scale of protests and so forth, is, wait a second, am I really happy with my life? Maybe there was some gnawing questions. Maybe there was a person who was always working and never had time for their kids, or the person always traveling that just wanted to stay home for a week, for a week straight. So this is really this time of slowdown as well, that we all kind of get to readjust and recalibrate and say, hey, how can we also take care of ourselves and get our own needs in order and have that kind of security and trust? So that way we can help give to others and eventually help give back to the world. And as I was recommended to look at a few movies, this reminded me of, in the Deep Impact movie, that there was a government official who quit his job to spend more time with his family when he found out about the impending asteroid. Didn't know whether it was going to hit or not per se, but just the sense of realizing that his family was more important, it just made him shift his life in different ways. All right, next slide. Okay. All right, so in the anatomy and physiology of how fear can really affect the body. So I know we talked a lot about, how it can manifest on the personal level, to our relationships, to the global sphere, how we can, talk ourselves out of things or maybe into things. So now coming into how the body works, what happens is when we see that threat, all of a sudden the hypothalamus and pituitary, which are two structures in our brain, all of a sudden send signals to our adrenal glands, which are two glands that sit on top of the kidneys, and those are going to release cortisol. This is our fight or flight. We are about to run from a bear. So that epinephrine gets us mobilized, and the cortisol is what keeps us going. And cortisol, which is also our stress hormone, which, you know, I know we're always getting told stress is bad, but once again, everything in balance, because we also need cortisol to survive. It is literally what wakes us up in the morning after we go to sleep. So, you know, if we backtrack to that fight or flight, you know, well, hopefully running from the bear, then all of a sudden, all these other systems like, you know, our hormones, our digestion, you know, and neurotransmitters as well, which are responsible for our mood, all of a sudden start taking a back seat. So this is where where I noted physically, we can have a good number of those symptoms come up as well. And then when we are in that stressed out state, to make sure we remember it, it imprints that memory into our hypothalamus, which is our memory, and the amygdala, which is our emotion. So if anything of that kind of stressful nature happens again, we're going to know right away. We're going to want to know what to do. And so now we come into this time that's stressful in ways maybe we haven't experienced, you know, synonymously, despite, you know, a few people I know being around from the 1918 Spanish flu. But we have 5 different generations on this planet right now. And that's a lot of different interpretations of how to cope with issues. So if we've been told how to cope with one way and all of a sudden that's not going to work for us, and now we need to cope with another way, can we trust that we do know what that other way is? So this is a lot of the emphasis of our body is imprinting those emotions, but how do we use our ego and our rationale to also say, hey, let's take a few deep breaths. You know, we don't need all this sweating. We don't need all, you know, the sugar coming in and the insulin going. We can really just step back and look at the situation and say, what can I do in this present moment? Because with stress, we've already had chronic stress as well in all these decades. So many of the diseases now, cancer, heart disease, you know, we're still on the rise of obesity despite all the fad diets and cleanses. So clearly something's not working. And then once again, that would be more going into, you know, the more medical sphere of things. But in the sense of stress is going to worsen things. It's like you're going here and you're dropping down. It's not, you know, like, oh, one feeds into the other. So there's going to be a lot of different issues affected, even such as serotonin, our happy hormone, which is mostly made in our gut. And if we're super stressed, it's going to turn off a lot of those functions in our gut that may make our happy hormone, as well as our immune system as well. So once again, having that balance both in life and within our body is so important. All right, next slide. Okay. And so coming into now the what to do, and then I'll also provide a number of different lifestyle tips as well, is that positive thinking can balance this out. And when I say positive thinking, it's not about, you know, think positive, stuff down the negative. It's about really stepping back and being able to say, hey, there can always be 2 sides to everything. What do I need to learn? What can I glean from this? And then, you know, moving through that way. So you're actually letting go of whatever the outcome is, and then being open to what, you know, what do you need to really listen to? What is that gut instinct of saying, wait, what do I need to do next to really help, you know, sustain that foundation? And that's the trust that you will always know what to do, because at the end of the day, everything that's happening externally is still external. You know, on the global scale, we may not be able to evoke change, you know, that we'll be able to really see for years or even decades. But on the personal scale, we really can go day to day. And this is where it comes down to recognizing fear as an emotion. So I remember when I gave a talk, there was a woman who said, well, I'm afraid of my whole family dying. And, first I said kudos for, letting that out, but to take a step back and say, well, we don't really know, if that's going to happen. So then what's something you could do to help transmute that fear? And one of the things mentioned was call the family and see how they're doing. Can she lend an ear? Can she help them? Because even though she can't control the outcome, she could control the relationship with them and see if they need anything. And maybe that was just a cue to say, hey, step outside yourself for a second. Let's really talk to others and make sure that they're doing okay as well. So, all right, next slide. Okay. So as we talked a lot about mindset, and this is also too, just knowing there's no right or wrong, because, well, if something's wrong, you'll know, just like if you know if something's right, you'll know, but still got to try and go for it first, because that's life too, and the journey, and, being able to fall on our face if we need. So as we work a lot on the mindset of things, then of course there's our physical body to help just relieve stress and even literally relieve like what's, been like stored up inside of us, any tension. Like when you're on the massage table and they hit a knot and all of a sudden you burst out crying and you had no idea where that came from. So synonymous to that. In the good side of everything, I've seen a lot of wellness professionals really step up and, do some personal training classes, group videos. I know YouTube, Crunch Gym, Orange Theory, no affiliation. They have a lot of great resources for even like 10-minute abs, for example. But I do recommend 30 minutes of daily movement, whether it's light stretching, walking, just to get some fresh air. If you are near nature or near a park, to just stick your feet in the dirt, because that really helps just literally reset your whole system from, even from the positive and the negative electrons and everything. So, and our heart's a conduction system too. So once again, can really help calm down our nerves in many ways. On the day-to-day, as I said, we are social beings, so reconnecting with friends and family, however you feel. If you really don't feel like connecting with someone, don't, there's ways to even text, social media, but just making sure there is some social engagement when you feel like it. So. And once again, this time is for you. What is that new hobby that you were thinking about, or that creative project? Currently, I'm at one of my childhood homes. I started going through my toy chest and made myself a pair of earrings. I haven't made jewelry in probably over 20 years. So, get creative. And, while we do have this time. Coming into natural remedies, so what I always recommend, we are about over 70% water. We are going to fluctuate, especially with whatever's going on in space. I mean, we are a planet kind of suspended in the middle of nowhere. And so with any different kind of movement, we can feel that. So really replenishing that, replenishing water, replenishing that energy is one of the best ways to have that motivation, good gut health, brain health, mental health. So you can always have something I recommend is like a 20-ounce water bottle. So you could have like a bigger water bottle, and then so you could have less of those throughout the day. So you're not keeping track of like crazy numbers. As I said, standing with bare feet in the dirt, and then having at least half a plate of vegetables, especially like lunch and dinner. So one of my favorites is dark leafy greens. So, and cruciferous like broccoli, cauliflower, Brussels sprouts, kale, chard. So these all pack a major bang for our buck when it comes to vitamins and minerals. And, whether it comes to making serotonin, dopamine, which are really good brain chemicals, great for our immune system, great for detoxification. So helping clear out any mental clutter so we can think clearer as well. Say, hey, how can we stay present? Great for balancing cravings as well, as I was recently hearing the term quarantine 15. So, and, you know, great for combating that. So really, all in all, wherever you are, you know, in your health journey, if you are interested, just start with one thing and do that for about a week or two, because it's more about sustainability, and the consistency is where you're going to see the difference. And if for whatever reason these don't jive, maybe they've sparked a new idea. And next slide, say last slide. And this is my contact information. So I'm actually all over social media. Please feel free to follow me there. I have a lot of different resources, including on my website. I have a lot of blogs, different recipes, and I do keep my recipes simple, you know, kind of that simple but effective. And there's my information below. So, you know, even being mindful of time, if you have any thoughts, questions, I would be happy to hear from you. All right, yeah.
Thank you, Serena. This is a fascinating talk. It almost feels like replacing COVID with an asteroid, and your talk is ready to go. So many things that are relevant to situations that would be exhibited across the board with different threats. And as you said, how to manage various situations is the key here. A lot of your advice, I think, would apply to many situations in life. So thank you very much, and thank you for the contact information. I think we're going to move next. Again, in benefit of time, we'll keep the questions to the end. And the next presenter is Mr. Liam Kinney, I believe, or Kennedy, Liam Kennedy.
Yes, hopefully you can all hear me now.
We can hear you very well.
You can hear me now, and you'll look, it just so happens I will switch to me in a second. But what I'm showing you right now is what I'm going to be talking about is this little product that I created now 7 years ago, which tracks the International Space Station and shows live video from cameras up on the space station. And it just so happens, because I do try to arrange this for every presentation I give, the International Space Station is passing over probably many of us who are here in the Los Angeles area. So what this is showing you right now is the display output from my little Raspberry Pi based computer. I'm not sure if this is full screen for everyone, but you can see the International Space Station with those 5 astronauts, well, actually 2 cosmonauts, 3 US astronauts, are just 480 miles away from us. And so that's just randomly what's going on right now. The space station is passing us by. It's a little bit off to our south and east. I live near Pasadena in a little town called Monrovia. And so it's now 540 miles away from me. And with that, I'll switch my camera back to me so you can actually see me. So this is me right here. Hi, everyone. Wonderful presentations today. I've sort of been taking in all of it. This is the actual device, the little Raspberry Pi computer, and you can see it's flashing really brightly here. That's indicating that indeed the space station is is above our horizon. And currently, also, if my USPS or Amazon delivery driver was coming up here right now, they're treated to a great big LED on the front porch of my house, which is also doing something like that, except it's a 3-meter long LED strip with like 150 LEDs. It really does brighten up the neighborhood at nighttime when it's passing by as well. So I'm sort of giving you a little bit of a preview of some of the capabilities of my little device here. And before I get too far into that, you know, in my presentation, I'll be sharing a little bit about my journey as somewhat, I would call myself an informal educator, astronomy, space, I used to be a planetarium lecturer at the Griffith Observatory. So that's sort of my sort of space expertise as an informal educator. But what it ended up, and I've also been a developer, you know, since I was in high school, which was a long time ago in the UK. But that led me to be able to create this type of device that I'm using as a means to inspire public interest and education around space. But before I get into that, I wanted to share my screen, because what I'm going to switch to is something that hopefully relates to the planetary defense questions and what it's like to be on the International Space Station and the sort of coincidence of all that. So I'm just going to share my screen. And here we go. Hopefully you can all see that. This is actually a tweet from Chris Hadfield, the Canadian astronaut of some fame. And what you can see here is an actual video snip from an experiment which is on the International Space Station. It's called Meteor. That's actually the, I can't remember what the acronym stands for, but it's related to viewing meteors really coming into the Earth's atmosphere. And Chris Hadfield made a point that he saw 2 meteors below the orbit of the space station. And of course, he thought that was rather cool. However, then right after that comes the question, wow, yes, these meteors are coming in at 30,000 miles per hour or so below the space station. And he also responded to some other questions saying, has he ever heard, you know, what happens when they hit the space station? Because yes, they do. The space station has some Whipple shields, actually named after the astronomer Frank Whipple, that a multi-layered Kevlar type material. And there is meteors do hit the space station, and Chris Hadfield confirmed that you hear it as a ping throughout the entire space station. But nevertheless, that's a curious thing. This was, as I say, filmed from an experiment that is, it's not, I'm not sure if it's active right now, but it is, when it is active, obviously for meteor shower times, it is put against one of the internal windows on the space station, pointing out nadir to show those sorts of things. Anyway, that was something that was really quite phenomenal. And with that, let me switch over to a presentation. And I'm perfectly happy if there are any questions. Ken or anyone else, you can jump in and talk the questions as well. So, because sometimes doing this, you don't really get to see the actual Q&A questions and things very easily. So let me just start my slideshow. So here we go. Hopefully you're seeing my presentation. Yeah, my email is pretty easy to remember, liam@issabove.com. And I'll just start off very quickly with where I came up for the idea of the ISS Above. I literally decided to create it just over a couple of weeks when I had nothing better to do. And I presented it actually at an LA-based space conference, a space unconference called Space Up. And I just arrived at their conference and showed them my little Raspberry Pi-based computer and gave a presentation. Just jump to a little bit about what this ISS Above does. Yes, so it displays live video from the space station, along with real-time information about the location, and also with details about news and passes over you. And as of now, there are now over 3,500 of these worldwide in 47 different countries. And they're in many hundreds of schools across the USA. And through a grant from the ISS National Lab, otherwise known as CASIS, I created a whole bunch of lesson plans and activities, and throughout across any sort of period of time when schools are in session, when students are actually at schools, it impacts around 84,000 students really throughout the school year. And this is just showing you a little map of where I've got these devices installed around the country. You can see there's the little icons for little people, I guess a parent and a little student there. Those are representing schools. And then there's a bunch of them in museums and science centers also around the country. So a little bit on where it started. Yeah, so I initially created my first ISS Above really just as a project to inspire my own grandchildren. Yes, I have 6 grandchildren, 5 of them in the UK and 1 of them here. It was my local grandchild, Owen, that I really wanted to impress with just how cool his grandpa is. Don't we all want to do that? Those of us that are of a certain age with grandchildren, you want them to think that you are cool and proud of their grandpa. So I created this thing really just to have my then 3-year-old grandson really know every time the International Space Station with those astronauts on board was passing by. Before I jump onto the next one, I'm going to stop my share and I'm just going to switch my screen so that it is showing you this other aspect. So again, I'm not sure if this is going to be full screen for all of you. I'm showing here live video right now from the International Space Station. It's actually just off Central America, and you're seeing a camera view which is actually coming from one of their higher quality cameras that they installed over the last couple of years. And it's obviously highlighting there the Japanese module on the International Space Station with the external experiment platform and the actual spacecraft that is docked there, I believe is, yes, that is Japanese. That is the HTV, I think, which is their module that arrived a few months ago. And unfortunately, we can't see Endeavour. That is actually blocked. It's on the other side of node 2, which is the node in between the Japanese module and the Columbus module up on the far right. And
excuse me, Dion?
Yes.
Yeah, there's a question. You know, there was a spacewalk, yes, a few days ago, right? Would this be able to catch it or something?
Yes. So this indeed. Thanks very much for your question. The spacewalk was indeed yesterday, and that was with Bob Behnken and Chris Cassidy, and they spent just over 6 hours. So yes. So this live feed was actually a little bit more dynamic as far as what it may normally do. Oftentimes you'll see views like this, and they do switch between many different cameras. So this feed can switch to different camera angles, and during a spacewalk, I actually switch ISS Aboves automatically to really follow the NASA TV feed, because that often provides more dynamic views of the spacewalk. But this particular live feed, it's on Ustream, and it's called ISS Live. And yes, so yesterday you were seeing all of that work. And that's a loss of signal. That blue screen there is what happens when the International Space Station may lose the high bandwidth signal with the ground. And probably with this particular community, with the AIAA, you'll probably have more of an appreciation perhaps of what is going on technically here as far as getting this signal down to the ground. It is on the back of a very high bandwidth, very high, I call it that. It's about 600 megabits per second of data is available for all space-to-ground data from the International Space Station, but it's through a network of really geosynchronous satellites called TDRS, and we've just lost that connection for a little bit. When that happens, the ISS above switches back to its ordinary screens. I'll give one more connection locally to that spacewalk, and it relates back to a visit early on in my doing the this ISS above gizmo. I actually got invited to a factory in Chatsworth, California. I think it's called Neotech. And they actually purchased an ISS above because that factory was involved in building the batteries that have just been installed. So in 2015, I made a visit to them, and I was just going there because they just purchased this ISS above and they were installing it. And the reason they wanted it is because this fits very well in the context of you're working on the International Space Station. Wouldn't it be cool that all of your employees know every time the space station is passing you by, which, by the way, is 5 to 8 times every day? So they installed this in their cafeteria. So I was going along just to sort of meet with them and sort of really get connected to what they're doing related to the space station. They are a subcontractor, I think, through Rocketdyne. On that same day, they were having a visit from Bob Behnken. Just random coincidence. So Bob Behnken, the astronaut who just installed the battery that was built in that factory where I went to go and meet them. And the point of Bob Behnken's visit is apparently a program that NASA does everywhere. If you are a subcontractor and you are building something that eventually will be key to life on a space platform or a rocket, you'll get a visit from an astronaut to underline how important it is that you do quality work, because the end result is about life in space. And so he was there to meet the employees and just present just how important it was that they do quality work. I then think it was the crowning glory of that, certainly for me, was that he literally installed the batteries that were made at that facility yesterday. So it was a 5-year journey to get to that point, and one that I had no real idea that that was really the actual context for that visit with those employees. But I thought it was just quite amazing. So let me just get back to a little bit more of my presentation here. Before I do that, I'm just going to switch back to the live stream for a second, just so as you can see that's where it is again. It really is quite extraordinary that we have access to these live views. And so let me now share my screen again, and I'll get back to my presentation. All right. That's my little video switcher there. Let me switch back to the PowerPoint. Here we go. All right. Okay, yeah, so I just wanted to just do a little bit here. And by the way, I have complete flexibility to curtail this presentation at any point. I mentioned that I took this idea to Space Up. When I was there and at other places, people were saying, you should really take this to a Maker Faire. And the top right photo there is when I was at the San Diego Mini Maker Faire, showing people devices that were lighting up every time the space station was going by. The next one is showing a coffee shop in Pasadena. It's very near Caltech. It's called Ginger Corner Market. And on their wall, they have had an ISS above since November of 2013. And that's because the owner there just loved the idea of having this to impress her customers who are from Caltech. Many of them, I found out, actually work on experiments that are on the International Space Station. Sort of quite an extraordinary, another connection. That's one of the things I really just did not understand until I really got into this. So there you go. And that's just a little 8-year-old giving a friend of mine a fist bump at how cool the ISS Above was at this Maker Faire. How I did the initial rollout of ISS Above was by actually doing a Kickstarter, and this is just showing you some of the press that I got during that program on some pretty important maker community websites. This is Hackaday, where a lot of people share their crazy, wacky, and amazing things. This is my wife. She loves it when I share this. Not. This is the initial shipping of all of those units, and I purloined my wife Anna, who is she runs she's actually runs CEO boards, private advisory boards. So this is not at all what she is known for in the world. But anyway, she was my QA, and we shipped a bunch of those. One of my early clients was actually Bill Nye the Science Guy, who got totally inspired by what the ISS Above does. And this was a random mention of ISS Above in the Wall Street Journal, and was responsible for a lot of ongoing interest in ISS Above. Just jumping through a little bit further stuff. So that was, 5 years ago. 2014 was when I launched the Kickstarter, and I started getting connected with NASA really very early on. And these are some of my key partnerships that I've actually established over the years. I've got the NASA logo there, not to represent any endorsement, as I very quickly, very specifically mentioned there. I do have a Space Act agreement with Johnson Space Center related to the education and outreach part of this, because it gives me some deep connections into many of the parts of NASA that are involved in the live video and other assets that are from the space station. I mentioned I had a funding opportunity with CASIS. They funded actually getting these into 100 middle schools around the country, and supported my development of lesson plans and activities that were created not by me, but by teachers who were using the ISS Above in their classroom. Space Station Explorers is actually their education program that has about 47 or so different education partner programs all underneath that. And the ISS Above is just one of those ways in which the ISS National Lab is supporting outreach and education. I'm very proud to be associated with them. Here we go. Just to give you a little bit of an idea of what my usual month is, I'll bring ISS Above into schools, science centers, exhibitions, conferences, and also a really amazing thing that started happening is that people who were running contacts between students and an astronaut on the space station via ham radio, they started to use the ISS Above because it was a really excellent way for them to have a really good display with appropriate information related to a live contact via ham radio when astronauts are passing by. That program is called ARIS, Amateur Radio on the ISS. I've personally been involved in about a dozen of them. I now have my own ham radio license, and I also communicate with the space station via a digital signaling system up to the space station. All of this is available to anyone who just wants to get a ham radio license. If I can do it, you can do it. And what that image on the lower right is showing is a bunch of students at the Kennedy Space Center Visitor Complex who were speaking with an astronaut as they were passing by. And in fact, I think that one was when they were passing by. They had a telebridge on that one. But either way, I've done it also for schools in Los Angeles. I did one most recently in October, was an elementary school in near USC in Los Angeles. Jumping ahead to one of my coolest things, about this was, as I said, NASA got interested in what I've done, and as many of you may know in this community, in fact, you're included in what I'm about to say, is that when what you do adds value to what NASA's doing, you'll often find people inside those organizations that are eager to sort of utilize what you're doing and support it in the way that they can on the basis of non-endorsement area. This was, what I'm showing you here is hands up. I'm pretending I'm seeing a lot of hands up after I ask you this question. Hands up who's been to Johnson Space Center ever. When you go to Johnson Space Center, the base has 4 gates, 4 entrances. So the gate 2 is what's called the high volume entrance to the base. And it's only open in the morning and in the evening, and it's where cars can very quickly drive in. Well, on that, they actually have this canopy, which has on it a bunch of LEDs, and someone at the facilities side of Johnson Space Center approached me and said, hey, can we use your box to control the LEDs so that every time the space station is passing by Johnson Space Center, you know, we can basically see that. And you know, it set this up. So this was a project I did. It was actually a year ago. Set this up. So now every time the space station passes by Johnson Space Center, particularly at night, you can't see these very well during the daytime, but at nighttime, it comes on, and it is visible for miles. Again, for anyone else here who has ever been at the, I think, what is it? It's the Hilton. Just on NASA Parkway, it's about 1.5 miles from this gate. You can see it from that hotel 1.5 miles away. So, and pretty amazing that it can be done just with a little box that I think I did a little bit of custom work on there, but nevertheless gives you an idea. Quickly jump through. Yes, I'm with a lot of schools and things like that. I do presentations. This is at my local high school in Monrovia, where they got an ISS above. That was actually donated by another person who's in the industry who wanted this high school to get this. It's also in libraries and museums. The one on the right there is a museum in Tampa, Florida, called Mosey, but it's all over the country. Again, a little bit of an inside look here. I wanted to let you know, so what I've got here are Susan Runco and Carlos Fontenot in that photo on the left. That's at Johnson Space Center. Carlos is ISS imagery manager for the ISS, and he is the one responsible for anything to do with live video. Or video or imaging assets that are on the space station. So he is a well-known person in the industry related to his expertise. Susan Runco is the co-principal investigator of a program that I featured a lot on ISS Above. It was called HDEV. That was a platform that gave dedicated live views of the Earth from the space station, from a module underneath the Columbus module. And that's now died, its end of life. Which is why I've switched to ISS Live. But nevertheless, these are the people that were really supporting a lot of what I was doing, and I can't thank them enough for their interest and support over the years. The image on the right is showing you ISS Above up on one of the monitors at the Deep Space Network Control Room at JPL. So yes, they do have my boxes scattered around NASA centers. It's really in every NASA center. And let me just switch on to the next one. Yeah, just doing some name dropping here. I did get to meet Scott Kelly and the 2 Russian cosmonauts there that were launching on the spacecraft for the 1-year mission. Scott Kelly is on the right side photo. You'll see me proudly standing there with Scott Kelly to my right, Gennady Badalka on my left, and then far left is Mikhail Kornienko. So it's sort of a story of me getting to do some of the coolest things ever. And let me just switch my video back to me. Excuse me just for a second while I switch back to that and switch back to the slideshow. There you go. So now you've got me again. Yeah, I just wanted you to see my face when I sort of really say, I'm really like a 6-year-old doing, just doing what he loves to do. That's my sort of passion for bringing this kind of awareness to everyone. I thought I'd also show you that's what a Space Act Agreement looks like. I expect that many of you have these in the AIAA. You have some of these with NASA. This is my own non-reimbursable Space Act. So I don't get the billions of dollars, but I do get some very valuable support by people that I respect and adore in NASA. So that's that one. Just very quickly, ISS aboves in classrooms. It's in private homes too. It's in many private homes all around the world. But these are examples of them in the classroom and being used. And they turn out to be a way in which students can become intimately aware of what's going on in space. And there's evidence, because we actually did some analysis using some educational researchers, that it really does help support increased engagement with students in many STEM areas. It's again me at another school. The other thing that I've been doing a lot of work with is one of my partners is with an organization called Magnitude.io, and they have an experimental platform, really a module that schools get in the classroom, which is a duplicate of one on the space station. So students actually grow a plant experiment, and at the same time, they can compare it in real time with the same experiment in space with slightly different conditions, of course, microgravity, but also much higher CO2 levels. And it really does allow students to appreciate, hey, this experiment that's in our library or in my classroom, it's just passed over the school again. So, you know, the ISS above lights up, letting them know not just that space station's above, but their own experiment in space is above them. Here we go there. This is just testimonials from teachers, which I'll just jump over, and I'll sort of declare that an end. I hope I literally have not seen the clock, so I don't know how far over we now are. I don't know whether I managed to bring forward things, but that's sort of it. That's my you know, I was really just sharing what is, again, my own sort of personal journey of passion and interest that's kept me busy for the last 7+ years doing this, and I wouldn't have it any other way. Obviously, COVID has impacted a lot of what I do. I no longer get to go to schools, but I do a lot of Zoom work. And the other thing that's impacted, of course, is that schools are no longer buying ISS aboves, which, you know, that's the way that this is impacting all of us, right? We're looking at new ways to sort of operate. And but with that said, if any of you do want to get any ISS aboves, you're welcome to do it. For those of you that are Raspberry Pi people, you can get the download image and put the promo code AIAA, and you'll get a very hefty discount off the price of that. It makes it only like $15 if you are going to download the image. I hope that was okay for me to do a little personal promotion there, but I really appreciate the opportunity to be on here. Thank you so much, Ken and Nahum, for supporting my presenting here today. I hope it was a useful and interesting add-on to.
Yeah, thank you, Ian. I think it was very inspiring, not just to your grandkids, But to me, we are sharing the same passion. I also give talks at schools on the topics of planetary defense, and I see the pictures that you just showed from your school visitations, and they are very similar to the ones that I
They
get,
are,
and
aren't they?
the thank you notes and the drawings. So I think both of us are inspiring the next generation of scientists and engineers, which is amazing. Obviously, the question that I had is that can you detect asteroids with your tool?
Yes. Unfortunately, that would
Not
be
yet.
yeah, that would be a no. But
Yeah, I know.
yeah. Jaxa may have something to say about that, though. I think do you have someone who is I think you have someone on from Jaxa?
Yeah, Makoto from Japan is going to be at the end.
Yeah.
He's going to talk about Hayabusa, which is
Yes.
different.
Yes, of course.
But very cool, very cool. I had, there is one question here that came during your presentation, which is it's a question about solar weather satellites. Is this something that you know anything about, or detecting effects from solar flares and things like this before they can affect your device, maybe?
No, so I don't think my device will play a part in that. Really, my device is a display device that you have in your home plugged into a TV. So I wrote the software. It's in Python, and it's doing all of the orbital calculations, pulling the live stream down to the device, but it's not doing anything other than that. It's a cool gizmo. And it can certainly be repurposed for many different things. So what I didn't mention, and your members may know this, Bill Nye is the CEO of the Planetary Society, and they have a planetary defense initiative themselves. So in fact, you may have met a number of them at your conferences. And just another connection there, just to show you the versatility of ISS Above, is they launched a CubeSat last year. In fact, it's practically a year ago on, the 25th was when it launched in the morning. It was on a Falcon Heavy launch. It was their CubeSat called LightSail. And that has just celebrated, they have just celebrated their 1-year mission. The ISS Above, at Bill's request, because if Bill says, hey, Liam, could you create this as tracking the light sail? And of course I said yes, because it's Bill. So the ISS Above can also track that. And it then shows different information, videos that are related to that program. So that's the sort of thing that ISS Above can be customized with, really on my end. It's not something that can be a user-based sort of thing, but users can select between tracking the space station or tracking the light sail, and it completely changes the output of the ISS Above related to that program. So to answer your question, where I was going with that is, yes, there's certainly a capacity for this device to be used to represent other missions and to represent other data that is from there. Think of it like a dashboard that allows someone to have a dedicated display, because many of you may appreciate, I do as well, on my phone, I can track the space station. I can see live video from my phone, but I've created this thing so that it is displaying a prominent display that not just you can see on your phone when you feel like it, but it's actually in view of anyone who is in view of that display. So
yeah, and I think that this is probably the most impressive part of it, is that a private citizen can actually build such a device such as yours. So it means that anybody could develop a similar passion on Python and a little, lab in his home to develop devices that will do fantastic things. So I'm thanking you so much. I think you and I should get together after COVID sometime to talk about our school experience. And really, many thanks. I'm clapping to you. It's really my kind of thing. And with that, I think we are going to move to the next talk, which I believe is going to be Phil, about his exciting movie,
Yeah.
Bill, the stage is yours.
All right. Thank you so
Bill.
much. Yes. So let me get my presentation up online and start the slideshow. There you go. Is it on? Yeah, everybody see it?
Yes, yes, it's clear.
Okay, so just a quick background on me. I've been an executive in the film business probably for close to 40 years. During the tail end of that part of my career, I ran across an article sometime in 2008 about a European Space Agency mission called Don Quixote, which is very similar to the DART AIM mission that's being put together now to practice deflecting a small asteroid of a binary asteroid system. And when I read this in 2008, I thought, at the time I was heading up worldwide distribution for IMAX, as well as heading up their development of documentary projects. And I thought, this would be a perfect film because it brings together, it sort of brings out into the open a very important topic that I knew nothing about at the time. So I decided that, from my experience in film, combined with my love of science, this was something that I needed to make sure happened. So about 3.5 years ago, I did a career change, and I'm now a writer, producer of film. And I'm almost done with this movie, Asteroid Hunters, that Nahum is featured in, as well as Mark Boslow from earlier. And it's all about the awareness of the critical relationship between media and planetary defense. And by the way, Asteroid Hunters, it's almost done. It's about 2 weeks away from finishing. And it'll start playing in IMAX theaters around the world, beginning in early October. The way I process the topic of planetary defense is necessarily through the eyes of your typical audience member, because it's important that the world at large understand what everybody on this conference is busy dedicating their lives to. And just like any movie, any effort to save the planet requires money. So protecting the Earth from a large asteroid isn't cheap, but it is cost effective in the grand scheme of things. But you understand this once you know the facts. So how does a government-led effort to save the world get the money they need? Well, you have to convince those who control the purse strings, the elected officials of the US Congress. But even they don't have unilateral say. Their power to decide the fate of any government program comes from the people. And in this country, there are about 330 million of us who need to be persuaded that saving our planet from the big rock is even worth it. Many believe an asteroid strike is one of those natural events that's unpreventable. So why spend money on it? And of course, everyone on this webinar knows better, but it's a fair question to a lot of people. So my mission became one to convince everyone that planetary defense is a worthwhile effort, but it comes with challenges. To motivate people, they need to care about the problem, and they also need to understand it. Fortunately, on the caring part, it looks like we have a little bit of a head start. The Pew Research Center did a study a couple of years ago that asked people, what should NASA be spending their time on? And addressing the threat of an asteroid came a very close second to that of climate change. And if you look at the negative the percentage of those who were completely dismissive of the idea, it's actually had the least negative pushback of any of the categories, including climate change. So people are interested in this topic, those that were surveyed by the Pew Research Center anyway. So the good news is that people care. This is something that they're aware of, but understanding the problem is another issue altogether. Unfortunately, too many people see science as this. It's cryptic, enigmatic, something that only people with PhDs would understand, and I understand it, and I can barely spell PhD. So I'm guessing no one on the webinar feels this way, but the people on, the people on the street, the average person is a different animal. And here, this picture I would regard as one that represents sort of a random cross-section of the people out there. And so how many of these people might understand the topic of planetary defense apart as being a science fiction subject for movies? Maybe this guy. Or not, otherwise not many. So the good news is every single one of us has a brain that's attached to multiple sensory organs. Maybe not everybody knows how to use that bundle of gray matter in the skulls, but the vast majority of us do. And luckily for me as a filmmaker, two of those incredible senses are the eyes and ears, something that all forms of media love. So the pictures, we all know that the pictures are worth 1,000 words. When you add surround sound, and in some cases 3D visuals, you practically transport audiences into whatever world you create. So they get a real visceral connection to the subject on screen. And just imagine if what they're seeing on screen is not some hypothetical, completely fantastical science fiction concept of an asteroid threat, but one that is grounded in real science. And some of that science is very complicated. So how do we use media to convey that? Well, through the eyes and ears, the brain is able to soak up a lot of science without ever needing to know the math behind it all. If you've ever thrown or caught a ball, then you know Newton's laws of motions, ballistics, and you'll even have a sense of force equaling mass times acceleration, all without once thinking about the math behind it all. And from there, it's just a baby step to orbital mechanics, which will help understand how we tend an errant asteroid that's on its way to Earth. But not all media is created equal. Some of it's just for fun. And this movie, among some others, I might blame as the reason why some people think stopping an asteroid is a totally wacky idea that lives in the minds of Hollywood filmmakers. I'm busy finishing a movie, as I mentioned, that is going to incorporate the ingredients that will lend credibility to the subject matter through the power of cinema. So not all facts are necessary. It's just the cool ones that we actually need to understand the subject, and that's sort of the fun of it all. The brilliant minds that are behind the pursuit of planetary defense are really, truly passionate people. They're passionate about the truth. This is one of the people earlier was talking about Maslow's hierarchy of needs. All of these individuals are at the peak of that pyramid as far as I'm concerned. And these four individuals, whom you know from the webinar, and Mark Boslow from earlier, and the two women here, Marina and Kelly, they're all involved in various aspects of planetary defense. And they're in the film to show that there are real people behind us, and the science is grounded, and it's all real. There's nothing that's fiction about saving the planet from an asteroid. So, I won't be just talking about these key ingredients. I'll be using them in my film, which is Asteroid Hunters, as I mentioned earlier. And the basic four concepts that my film talks about is: where do asteroids come from? How do we find them? How do we plan for impact? Which was referenced earlier about, where FEMA gets involved, just simply evacuating and getting out of the way. But better solution being, how do we keep one from hitting? But it's not all about my movie or about movies. There's other media that are really helpful as well in getting the message out. Millions follow a myriad of sources of scientific endeavor. Before COVID-19, something going viral was a good thing. But when it comes to knowledge and understanding, it still is. And and all of that brings us really back to the very beginning, which is the money. The money is the thing that drives all of it. I've often likened the pursuit of planetary defense as something like the fire extinguisher in your home. You compare the price of that fire extinguisher to the price of your home, it's a pretty small value compared to the thing that it's intending to save. When you think of the trillions of dollars of economy, not to mention the 7.77 billion lives on the planet, spending a few $100 million a year on planetary defense is money well spent. And that my film is intending to convey this, and this idea, not only just through my movie, but through all of the other forms of media, can help the public understand that and drive the decision makers into allocating the necessary monies that will do one thing that I think we all care about, and that is save a planet. And so that's it for me. Hopefully the people that follow will be able to get close to back on schedule.
Thank you, Phil. Again, I'm very happy that you developed this passion some 10 years ago and to contribute to your film. I'd like to repeat something that you like to say, that you're going to use your film to deflect an asteroid with a movie. So
Exactly.
that is your quote. So
you just need lasers and missiles and nuclear explosives.
That's right. I think that the international awareness that your movie is going to develop is probably going to be the most powerful tool in developing the next means of planetary defense, by simply having the public involved and pressing on the decision makers. So I'm really, really admiring you for that.
Well, thank you, Nahum, because you, as well as others, have been at aerospace, as well as with NASA and JPL, and Los Alamos and Sandia National Labs, and on, have been incredibly helpful in making sure that I got my facts right with this film. And you know, the good news for me in trying to get the word out is you really have no more a powerful medium than the IMAX format in really impressing an audience and helping them not only intellectually understand the topic, but also get a visceral understanding, an emotional one. And when it's grounded in truth, which we show through the various settings in which the movie takes place, it shows people that, you know, this is real. There's only one movie set that was used in this movie, and that was to show the hypothetical aspects of the film. In other words, what we would do if an asteroid was coming our way, and what would we do to deflect it. But it's all grounded in actual science. We went to great ends to make sure that the science portrayed in the film adhered to the understanding of you and your peers on how it all works. So there's a lot of people to really thank and to be appreciative of in helping make this project become a reality. And lucky for me, it's just about there. And so they're going to drop the trailer for the film on June 30th as a tip of the hat to Asteroid Day. So everybody will be able to start watching that trailer beginning this Tuesday, and look for the film in your neighborhood IMAX theater beginning in October, wherever in the world you may be.
Amazing, amazing. I can't wait for the trailer and for the movie to come out. And I know many of my friends as well.
Good, awesome. Well,
thank you,
Ken, for having me.